We're now going to learn about the limitations of for loops and the limitations about the amount of information we can store in a variable. So let's go to Xcode, and we're going to select get started with a playground here, and we're going to call this limitations of for loops, and we're going to go ahead and press next, and we can press create. I'm going to go ahead and enlarge this project. So the first thing we're going to do here is we are going to create a variable. We're going to say var wheat is equal to 1. And what we're going to try to solve in this problem is the wheat and chessboard problem. And the way this works is if we were to start at the first square in a chessboard has 64 squares on it, what would be the total amount of wheat on the last square if each subsequent square we added a piece of wheat or a grain of sand? So we're going to start off with the value of wheat is going to be 1. This we'll put on our first square inside of our chessboard. And then we're going to say for var I is equal to 0, and I will represent the square we're currently on. So I must be less than 64. And then we're going to say plus I. This is just a different way of writing I++, which is basically saying increment or add 1 to I each time we go through our for loop. Generally, by saying plus I, you're saying, okay, use the value of I and then add 1 to it. Whereas I++ is saying add 1 to I and use it. But in the case of our for loop, it makes no difference. So I just want to show you this different syntax here in case you see this used in code. And then what we're going to do is we're going to write wheat is equal to wheat times 2. And we see we're already getting an error here because it's running out of space. We see it's running 62 times and then it's terminating. But let's go ahead and add a print line statement here. We'll say location on board. We'll pass in I, which is our current location on the board, and pieces of wheat. And we'll pass in our wheat here. And let's go ahead and take a look at this printout. So we see we start at 2. We could actually even reduce this. We could start at 1 if we wanted to, but that's fine. The idea here is that we are eventually going to run out of space, and that's the important thing to see here. So eventually we get down here to 61 pieces of wheat. We have this very large number, and essentially what's happening here is this number eventually, if we double this, gets too large for the integer. There's just not enough space to store it in the integer here. And as a result, this for loop terminates, and we see that we are actually getting this error message here. Execution was interrupted. So you just need to be careful. If you're going to use ridiculously large numbers, you're going to want to figure out ways in which to store these properly. This really shouldn't be an issue for anything we're going to write in this course in terms of code. But it's nice to note that there are limitations on the amount of information you can put into a variable and to actually see that print out to your console. So in this challenge, we're going to want to use a for loop to print out the number of bottles of soda on the wall. You can just print this out to your console, and you can even do this in the playground as opposed to our usual challenges where we have to do these in an Xcode project. Now, hopefully you can't see my solution over here. It is on the left. But what I want to show you is that once you get your for loop working properly, you can press this little white button here to see the value history. And this will open up your console. So let's just press that. And we're going to be able to see our console output. And this is what your console output should look like. So it should show the number of bottles of soda on the wall. It should start at 99 and should decrement down to 1, and at the end it should say no more bottles of soda on the wall. So best of luck with this challenge. Hopefully you can guess that you need to use a for loop. Maybe you're going to throw some control flow in there, if else statements, that sort of thing. And if you get stuck, definitely check out the 99 sodas challenge solution in the next video and solve the 99 sodas challenge. So we're going to go ahead and open up Xcode. And we're going to go ahead and we can actually create this in a playground. That's perfectly fine here. And we're going to call this the 99 sodas challenge solution. I'm going to go ahead and press next and press create. And I'm going to go ahead and remove this first variable here. So what is the goal of this? Well, we want to start with 99 bottles of soda, and we want to reduce one each time we go through a loop, a for loop, and we want to get all the way down to 0, right? And when we do get down to 0, we want to say that there's no more bottles of soda on the wall. Hopefully this is a hint that maybe we need to use some sort of control flow. So we're going to say for var bottles of soda, we're going to set this equal to 99. We're going to say bottles of soda must be greater than or equal to 0. We want it to be able to get down to 0. And then we're going to say minus bottles of soda. Or we could say bottles of soda minus. That'd be completely valid as well. So the first thing we're going to do is we're going to write an if statement. We're going to say if bottles of soda equals 0. We're going to say print line. And we'll say no more bottles of soda on the wall. And then we can add an else statement. We'll check this over in the console printout in just a second here. We're going to say else print line. And we'll say bottles of soda. And then we'll say outside of this, bottles of soda on the wall. So let's just see the printout here, and then we'll discuss what's happening here. So we're seeing that 99 bottles of soda on the wall is printing out, and it goes all the way down, and at the end we see no more bottles of soda on the wall. So that's perfect. This is working. But let's talk about our code here. So the first thing we're doing here is we're creating a variable inside of our for loop, and we're setting its initial value equal to 99. We want to start off with 99 bottles of soda. We're also specifying that bottles of soda must be greater than or equal to 0, because each time we reduce the number of bottles of soda by 1, we want to make sure that the bottles of soda does not go below 0. We want to say that it must be greater than or equal to 0. So once we're inside our for loop here, we know that we have access to the variable bottles of soda, and we're specifying that if the bottles of soda is equal to 0, that there are no more bottles of soda on the wall. So we're just adding a print line statement for that. And then we're adding an else statement. We're saying otherwise print out that the number of bottles of soda on the wall. So we have access to that from our variable. And we're just using some string interpolation here to say, okay, the number, and then we're going to do bottles of soda on the wall. In our next series of videos, we're going to be learning about object-oriented programming. Object-oriented programming is a programming paradigm that groups data and tasks into separate concepts. To communicate with a computer, we need a common language. This is very similar to communicating with humans when you need a common tongue. In our case, we're going to be using Swift to communicate with, of course, some things going on under the hood. Our brain organizes information into objects. So having a computer do this will allow for much easier communication. Essentially what we're going to do is we're going to be setting up templates or blueprints where we're going to be able to create multiple instances of a specific object. And the way we're going to be able to define what this object should have, we'll be using structs and classes. Now we're going to start with structs. They're a little bit more simplistic than classes, and there are some differences between the two, although they have a ton of overlap, which we'll see in just a bit. Now if this is a little confusing, don't worry, we're going to be spending quite a bit of time creating different instances and figuring out what this means. But essentially what we're going to be able to do is we're going to be able to take one blueprint and create quite a few instances from this specific blueprint. Now, what blueprints have we seen so far? Well, we've seen examples of buttons, text fields, and view controllers, and these were all defined and created by Apple. And basically what we were able to do is we were able to create a single instance of a button or a text field, and then we were able to adjust what the attributes of that button or text field should be. And we saw in some of our projects that we were able to add multiple buttons or multiple text fields, and each time we were able to drag it in without any problem. Well, that's the beauty of this blueprint. We don't have to keep recreating this thing over and over. We're able to package this functionality, and Apple goes ahead in these examples and has already gone ahead and packaged this functionality for us so that it's very quick for Apple and Xcode to keep supplying us with all these buttons and text fields. Now, I've included some other examples on this slide here about future objects or instances that we'll be taking a look at. So we'll be able to create a tiger blueprint. We'll be able to create multiple tigers from it. We're going to be able to create a car blueprint and be able to create multiple car instances. Now, you might be saying to yourself that this seems like quite a bit of extra work. It's a little bit confusing. Why would we bother doing this? Why can't we just write all our code in one place and, just go down and evaluate the code line by line? Well, it's really difficult to debug code that's written like this and really difficult to understand what's going on. It also saves us quite a bit of time using these blueprints so that we don't have to keep rewriting code over and over. And it really allows us to mimic how humans think, because we as humans generally group things into abstract ideas. Now, I know instances and object-oriented programming seems very scary right now, but we're going to continue to give you examples, and we're going to go ahead and create these things ourselves, and you're going to see very quickly that it's a great way that we can encapsulate information together and reuse functionality inside of our application. So in this lesson, we're going to learn more about structs and instances, and this is going to be a follow-up to our last video. So in our last video, we started learning about object-oriented programming, and we talked about the idea that we can model our world in terms of objects. Now, the way in which we create these things in Swift is through structs and classes. We're going to start with structs because structs are a little bit more simplistic. And here we see that with a car struct, which we're going to call our blueprint, we're able to create multiple instances of our car. And we see that we get 3 different car variations, but all of these are coming from a blueprint. And this is kind of a super duper blueprint to create such different cars here. But, if we were using all the same model, we could maybe paint different colors on top. At a very high level, all these cars share certain attributes, right? They're all able to drive. They all have 4 wheels, right? They all have some sort of roof apparatus, even though our first car instance here is a convertible car. It says that foldable roof on top. So what we want to do is we want to think about the idea that a blueprint is this kind of outline that we can set up. And from that, we're going to be able to create an instance that already has kind of placeholders set up where we're going to be able to put a color. It's already going to understand that it has 4 wheels, but maybe we define what type of wheels it has. Now, for those of you coming over from Objective-C, this is going to seem a little weird, right? The upgrade to Swift allows us to add methods and properties to our struct. We weren't allowed to do that in Objective-C. Now, our struct can create instances, whereas before we weren't able to create instances in Objective-C because a struct was a primitive back then. For those of you who have never seen Objective-C, this should be a lot easier, this transition, to think about structs as creating instances from our blueprint. And instead of calling things objects moving forward, we're going to refer to each instance. So we could say car1 is an instance of our car struct. Car2 is another instance, so we'd have 2 instances. And car3 would be another instance. So in this case, we'd have 3 instances of our car struct. So when I use the term instance, just think of, okay, this is an actual, it was created from some sort of blueprint. And when I talk about the car struct, I'm referring to the blueprint itself. We're going to get started on a brand new project, and this project is going to be called Lions and Tigers. In this project, we're going to get a chance to play with classes and structs. We're going to start off with structs since they're a little bit easier. And we're going to get to see the similarities as well as the difference between the two. So it'll really help you understand when to use a class, when to use a struct. We're also going to be taking a look at arrays and adding our own model instances to the array. It's really going to give us a chance to understand how we can encapsulate information ourselves. And in so doing, we'll start to understand what our classes and structs that Apple has pre-created for us, and why do we have access to things like functions and properties? How do these things get created, and what are they actually doing below the surface? So let's go ahead and we're going to select Xcode here, and we're going to create a new Xcode project. And I'm going to choose iOS application, single view application. We're going to name this project Lions and Tigers. And we're going to make sure that we have an organization name. We're going to use organization identifier. Make sure the language is Swift and our device can be universal. We're not going to use core data, so we don't need to select that option. We are going to create a Git repository on the desktop here. So let's create this. And let's go to our storyboard here. And this time we're going to go ahead and we're going to switch our class size here to be final values, all iPhones in portrait. So we're going to choose this bottom left-hand corner one, as we'll deploy this application, the iPhone 6. Some videos we're doing the iPhone 5S. Some videos we're just kind of dropping things in. We don't really need to worry about the layout, but in this video we kind of want to size things nicely. Specifically, we're going to have a toolbar in here that's going to run across the very bottom. So very important that we do this. Now, as you switch this to say compact, width and height regular, if you go ahead and you save this to GitHub and you pull it down, you won't see these items unless you switch this to compact, width, and regular height. Right? So if you just open this up and you see any, if you make changes to this here, you won't see the changes. So it's really important that you go ahead and you switch the two. Otherwise, you won't be able to see the items. So I have this on compact, width, and height regular. And this will give us a nice big screen here. Now, we're not going to use all this screen space. If we were deploying to the 6 Plus, we can use all this screen space. But what I want to quickly show you is this really cool website called mydevice.io. And we can see that we have a width of 375 and a height of 667 for our device here for the iPhone 6. So that's going to be the size we're going to drop in for our background view. In fact, let's do that now. Let's go ahead and search for an image view, and we can drag this into our view controller here. Now, we don't want this to take up the whole size of this template we have here, so we're actually going to shrink our image view down a little bit. So we're going to go into the size inspector here with our image view selected, and let's change the width. We're going to set this to 375, and we'll set the height to 667. And we'll see that this is going to drop an image view in here that's going to be a bit smaller than our template here, but we'll be able to properly align our items and have this item display in the iPhone 6 properly. So this is one cool way that we can resize things for different devices. Later on, we'll figure out how we can do specific devices and have different sizes for everything. We're also going to figure out how to do auto layout in the future, which will have these items auto resize based on the device. But for now, we're just going to be testing in the iPhone 6. Again, we're really just focusing on the code and not building like beautiful UIs. So the next thing we want to do is we want to go ahead and we want to add a toolbar here. And our toolbar is going to allow us to add kind of an item at the bottom here that's going to allow us to have a button on there. We'll figure out how that works in just a second. So let's go ahead and add a toolbar. And we're going to drag this into the bottom here. Now, we're going to want to resize this toolbar. So we're going to make sure we have our toolbar selected. Actually, let's just do this in the size inspector here. And we can set this to be 375. So our toolbar will be the same width as our image view here. And we see that we automatically get access to an item on here. This is a bar button item. And this will be clickable. So when we press this button, we're going to be able to cycle through a bunch of image views, specifically lions and tigers, inside of our application. Now, right now, this title, if we go to the attributes inspector, is named item. And let's change that. Let's switch this to next. So we're going to say, okay, let's go to the next animal. And let's also figure out how to make this bar button item go to the right side. So we're going to go in here. We're going to look for our bar button item. And we're going to see below here we have a fixed space bar button item, and we also have a flexible space bar button item. Now let's grab the flexible one. We can drag this into the left. It's important that it's to the left of here. And this will automatically move our button over. Now we could have also used a fixed space bar button item, and the difference basically is a fixed space bar button item. We can determine how big it is. With the flexible one, it's automatically going to readjust based on the amount of space available. So if we added some additional bar button items in here, we could drag this in here, and we could drag another flexible one to here. We'd see that it auto resizes these items. But since we only have one bar button item, we want it to be all the way over to the right. It's easy just to grab a flexible space bar button item, and it'll automatically push it all the way over to the right for us. So that's pretty cool. We also want to add a few additional elements above our UI image view here. Now, it's important that we add these second because we want these to appear above the image view and not behind it, right? If it's behind the image view, we wouldn't be able to see these labels because our image would eclipse it. So let's go ahead and search for a label in here. And we're going to actually drag in 3 different labels here. 1, 2, and 3. And let's just kind of size these up here. Let's also enlarge them. And we're also going to change the attributes in just a second. So let's make sure all 3 of these are larger. You could also copy and paste these if you wanted to. I like to just drag them in one at a time. In case there's some connections associated with them, if you copy and paste a UI element, it's going to also copy and paste the connections you have. So I like to avoid issues whenever possible. Let's change the first label and let's call this name. And let's change the second label and we'll call this age. And let's change the third label here and we'll call this breed. And we can select our first item here. We're going to go ahead and change the color and let's make it white color. We can do the same thing with our second one here, as well as our third label. The final thing we want to do is we want to hook up all of our UI elements here. So let's hold down the Alt key and press on viewcontroller.swift. And I'm going to quickly just close out our panels here so we have a little bit more space to work with. And the first element we're going to want to hook up is going to be our image view. So let's make sure we have our image view selected in our view controller scene. Incidentally, if for some reason your labels were behind your image view, that would be based on the order here inside of your view controller scene. So the items that appear at the top are the furthest back, and then items closer to you appear after. So we can see that by having these 3 items after our image view, they appear above. If you drag it above, we see that it gets hidden by the image view. So that aside, we're going to hook up our image view first. So let's make sure we have that selected in our view controller scene. And let's hold down the control key and drag to our view controller file here. And we're going to release, and we're going to call this first item my image view. And we're going to make this of type UI image view, and the storage can be weak. It's also going to be an outlet connection. And we're calling this my image view. We could also call it image view. I'm trying to show you some different ways we can name things. Just so when you see them, it just becomes really obvious that this is a variable name that we created. And you just get used to this process of creating variable names for all of your outlets. So we're going to call this my image view. And we're also going to hook up our 3 labels here. So let's hook up our name label next. And we can make this an outlet connection once again, type UI label, and the storage type will be weak. So we can call this name label, connect this up. And let's do the same thing for our age. We'll call this age label, type UI label, storage will be weak, and this will be an outlet connection. And finally, let's hook up our breed label. And this, once again, will be type UI label, and the storage type will be weak. Now the final thing we want to hook up here is going to be our button, and this is going to be an IB action. So let's go ahead and do this below did receive memory warning. So we can choose the next button. Notice that I'm selecting this in my view controller scene because I accidentally selected my toolbar there. So it's really good to confirm that you're using the proper item in your view controller scene. So I'm going to hold down the control key and we're going to drag in here. And this is going to be an action, it's a button. So we're going to say next bar button item pressed, and the type will be UI bar button item. And we can connect this up. So it's time to make our first struct. We're going to go to File, New File with our project open here. And if I can properly select that here. And then we're going to go to iOS Source, and we're going to choose Swift File. And this will just generate an empty Swift file. In the future, we're going to be able to use the Cocoa Touch class if we want a subclass, a pre-existing Apple class. But for now, we just want an empty file, so we'll choose Swift File. And we can choose Next. And let's name this Tiger, and we can create this. So we automatically import Foundation, which is going to give us access to the Swift programming language. We're going to see later, in order to get access to the UI elements, specifically in UI image view, we're going to actually have to manually import UI kit, but we'll get there. For now, we actually just want to set up our struct. So it's not that many lines of code. We're just going to literally type in struct, which is going to be our keyword. we're going to give our struct a name, and we're going to use a capital letter, because capital letters we're going to reserve for class and struct names. So we're going to use a capital letter here, and then we're going to add curly braces. And inside of these curly braces, we're going to be able to define what the blueprint for a tiger should look like. So what can it do, or what functions does it have, and what attributes does it have, or what properties does it have. So we'll figure out how we can add properties and functions to a tiger struct in our next series of lectures together. But when making a new struct, just remember that we have to create a new file, and then we're going to use this struct keyword, and the name that follows the struct keyword is going to be the name of our struct. So now we're going to be able to create tiger instances, and we add our curly braces because inside of the curly braces we're going to be able to define what the blueprint for our tiger will entail. In this video, we're going to start adding some properties to our tiger struct. Now, we've created properties in the past, specifically when we've dragged in UI elements and added them to our view controller. We are actually adding properties to our view controller. Here we're going to add properties. Now, these aren't going to be on our storyboard. We're just going to add these. And every time we create a tiger instance, it will automatically have access to these properties. And we'll say that our tiger instance will encapsulate this information. I think one of the easiest ways to visualize this is to just see it. So let's go ahead and start adding a few properties. Now, we're going to use this var keyword. We're going to say var age equals 0. And this doesn't look like anything special, right? We've written code var age is equal to 0 before in our playground. We've also done things like this in, different IB action functions. However, in this case, we're not writing this inside of a function. We're just writing this inside of curly braces defined for our struct here. So this is actually a property. And when we create a tiger instance, we're going to be able to access the age property or the age attribute by saying, my tiger, or whatever we name our variable for our tiger instance, .age. So we'll get to see that in a future video when we actually instantiate our first struct. But for now, we're just setting up these properties. And why are we setting it equal to 0? Well, we could just add the type here. So we could say instead var age int, and we could add an exclamation point at the end here. And this would be valid too, but we would immediately be required to add this age. And I quite like doing it this way because we're giving it a default value. So there's no chance of it not getting set and causing some sort of other issue in our code. I will always just set a default value for my properties when I create them. So there's kind of multiple ways you can do this. Apple really tends to do this exclamation point. And this works often when we're setting up our IB outlets because we know that this element is going to exist in our storyboard. But for our cases, I just really like to set up the default value. So that's how I'm going to show you how to create our variables, at least through our first few projects together. So let's also go ahead and create a name property. We're going to say var name is equal to 0, is equal to double quotes, because this time we want it to be an empty string. And notice that we're automatically allowing Swift to figure out that name should be a string, and that we're going to give it this property name of name, and then it's a variable, and then it's going to be able to be changed in the future. So this is another property that we have here. Let's create another property and say var breed. We're going to set this equal to double quotes here. And this is going to be, once again, a string, and its variable name will be breed. And we'll be able to access this using our dot notation dot breed in the future as well. Now we also want to go ahead and add an image. And in order to do this, we're going to say var image is equal to UI image. And we're going to add a custom initializer here. So we're going to say named. And we're going to see that right now we're not getting an autofill. So how can we fix that? Well, let's go to the top here and let's import UI kit, because this way we'll have access to the UI image class. And now we can pass in named, and we can just pass in double quotes here. Now, we need to be a little careful with this image property because right now we are setting a default. But if our computer program goes and tries to find an image named, and this is just an empty string, it's not going to find anything. This will likely cause us some problems down the line. So we need to remember to use this image. And what we could do in the future would be to just add a default image and just set the name to default. This would actually be a really good debugging tool. If for some reason we saw that default image appearing when we were doing testing on our application, we would know that something wasn't updating properly. So that's one strategy you can use. But for now, just leaving as double quotes is perfectly fine. What the real purpose of this video is to understand how we can add properties to a struct, and we're going to try to understand that now our tiger instances have an age, a name, a breed, and an image, and they all have default values. We set this to 0, empty strings, or just a UI image instance. We're instantiating it, but we're not actually going to go ahead and give it an image yet. So that's this could be troubling, but we've talked about that. And now our tiger instance has all these properties automatically created or added to it when we create instances of this blueprint. Now we have our tiger struct set up, we want to figure out how we can actually create a tiger instance. We're going to go over to the viewcontroller.swift file, and this is a really good place to test this out because we know in the viewDidLoad function, this function will automatically be called, and we're going to be able to do some testing code here. So let's go ahead and create our first tiger instance. How do we do that? Well, we're going to type in var. We're going to say my tiger is equal to, and we're going to say tiger, and we're going to add some parentheses here. And this is just the default initializer. It's going ahead and creating a tiger instance. It's not setting any additional properties except for the defaults that we set up in our tiger struct here. And now we have a variable named myTiger that is of type tiger here. And we can now set different properties for the myTiger instance. So we could say things like myTiger.name. And notice we're using this dot notation. We've seen properties before. We've seen properties of things like labels, right? We've been able to access the label using the variable name. And then we were able to access this different properties using this dot notation here. And we know that name needs to be a string. So we could say something like Tigger. And we can also access myTiger.breed. And we can set this equal to Bengal. And we could do myTiger.age. And we could set this to 3 because this is an integer. And finally, we could do myTiger.image. And right now we don't have any images. So I'm going to go ahead and add our lions and tigers assets. I've already gone ahead and downloaded this. If you haven't downloaded it, go ahead and do so. So from my desktop, I'm just going to drag this folder into my supporting files here. And I'm going to make sure to check the options for copy items if needed. We're going to add folders to, and we're going to select the option to create groups. And this is going to create a nice grouping for our assets here. And we're going to add to targets, and we'll make sure that the lions and tiger is selected. So we can press finish here. And if we go ahead and open up this grouping now, I want to point out one thing here. The lioness is .jpeg, and so is the lion cub too. So this is just something to keep in mind. If you specify the file extensions, just make sure to specify both of these, that they're different than the JPGs. So we'll see that in just a bit. For now, we want to set the image for my image. We're going to set this equal to UI image, and we're going to do named. We're going to do Bengal tiger.jpg, and this is going to create a default UI image instance with the image for the Bengal tiger.jpg file. This is why we wanted to pay attention to our file extensions. And this essentially takes one string as the parameter for our function here, named, and this will return an UI image instance with the Bengal tiger as the actual data that will be displayed for our UI image instance. So we're going to be able to set that equal to myTiger.image, since this is a UI image property of the tiger struct that we created. So we're not actually going to be displaying that yet, but we will in just a bit. Right now, what we're going to do is we're actually going to add a print line statement so we can see how we can access all this information from the myTiger instance now that we've set up the values for each one of these properties. So let's add a print line statement. And we're going to say my tiger's name is, and we'll pass in myTiger.name. And we're going to say its age is, and we'll pass in myTiger.age. And we'll say its breed is, and we'll do myTiger.breed. And then we can say, and its image is, and we'll pass in myTiger.image. And basically what I want to prove here is that we're able to set each one of these properties, and then we're able to get these values back, and they're saved to the variable myTiger, and we're able to access them using each one of the property names, right? So we can both set a value for a myTiger instance, and we can get a value back, right? And this is what we call getting and setting of properties. And now if we take a look at our console here, let's go ahead and just enlarge our console. We see myTiger's name is Tigger, its age is 3, its breed is Bengal, and its image is, and it shows us the UI image instance. It also shows us where the memory address is located. So it's a little bit more complicated. We don't have a nice string representation of our image, but we do see that the UI image instance exists in memory, right? It is being created, and we are able to access it using the myTiger.image property here. So in this video, we're going to figure out how to use our Tiger instance to actually do something. Specifically, we're going to use our Tiger instance to be responsible for updating our UI. So let's go ahead and update each one of our IB outlets that we created with the information from our Tiger instance. So let's first say myImageView.image is going to be equal to myTiger.image. And then we're going to say nameLabel.text is equal to myTiger.name. And then we're going to update our age label. So we'll say ageLabel.text is going to be equal to, and then we're going to do string interpolation here. And we'll put in myTiger.age. And finally, we want to update the breed label. So we'll say breedLabel.text is going to be equal to myTiger.breed. Now let's go ahead and run our application, then we'll talk about our code here. Hopefully it's fairly straightforward. But we do see our image now appear here. We see Tigger, 3, and Bengal are all appearing as well. So what do we do here? Well, we have 4 IB outlets. We have my image, name label, age label, and breed label. And each one of these has a property we're updating. So for my image view, we want to update the image property. And we have a UI image instance saved, but we saved it as part of the myTiger struct that we created here, the instance of Tiger here. And with that instance, we're able to say myTiger.image. We're able to get back our UI image instance, and we're able to update the image property of myImageView. So we're going to do the same thing for our labels here. We're going to access myTiger's name, right? And this name instance, right, is a string, so we can update nameLabel.text. With the age label here, we're getting back an integer, so we need to do string interpolation here to insert the integer and make it a string, so we can update age label. And finally, we're going to access the string that's returned from our breed property here of myTiger, and we're going to be able to update our breed label. So in this way, we can access all the information we've encapsulated inside of the myTiger instance and use it to update our UI. So we can see a practical application of creating our own model instance, right? Specifically, we're creating a Tiger struct that we're using to model some information or to create a blueprint that we're going to be able to create multiple Tigers from in the future. So now that we know how to create a Tiger instance, let's now prove that the Tiger struct is reusable by creating a few more instances of Tiger. Now this is going to seem a little repetitive, but we will be using all these instances in the future, and we're going to use a slightly different name convention for the 2nd through 4th Tiger. We're going to create 3 more Tigers here. Rather than saying like myTiger 2, we're going to say 2nd Tiger, 3rd Tiger, and 4th Tiger, just so we can see that this variable name we're going to specify, but the way in which we're going to create these instances and access the properties is going to remain consistent. So hopefully you'll be able to see both the similarities and contrasts between these additional struct instances that we're going to be creating here. So let's create a second instance of Tiger, and we'll call this instance 2nd Tiger, and we're going to set this equal to Tiger. Notice that we're initializing this the same way, and then we're going to be able to say 2nd Tiger.name is going to be equal to Tigress. And we're going to say 2nd Tiger.breed is going to be equal to Indo-Chinese Tiger. and we're going to say second tiger dot age, and we'll set this equal to 2. And we'll do second tiger dot image, and we're going to set this equal to UI image. We're going to do named, and we're going to do Indo-Chinese tiger dot JPG. So we're just creating a second instance of the tiger struct here. And notice that we have access to the same properties here because we set that up in our tiger struct here, but that we're giving it different values than we did for our first tiger here. Also notice that we're naming the second tiger instead of my tiger, right? So we're giving this a different variable name. So just like we were able to create multiple integer instances like X, Y, Z, we're also now able to create multiple tiger instances. We can create a third tiger. So let's say var third tiger. And let's set this equal to a tiger instance. So we're going to instantiate it, or actually create this instance using these parentheses once again. If we don't do this, the third tiger instance doesn't exist. We haven't actually created this instance in memory, so we can't set any values for it, right? So we need to make sure that we're creating the instance. So let's say third tiger dot name is going to be equal to Jacob. And we'll say third tiger dot breed is going to be equal to Malayan tiger. And we'll say third tiger dot age, and we'll set this equal to 4. We'll say third tiger dot image. We're going to set this equal to UI image named, and we'll pass in Malayan tiger dot JPG. And finally, let's create a fourth tiger here. We're going to say var fourth tiger, and we're going to set this equal to a tiger instance, and we'll say fourth tiger dot name. We'll set this equal to spar, and we'll say fourth tiger dot breed is going to be equal to Siberian tiger, and we're going to say fourth tiger dot age is going to be equal to 5. And we're finally going to do fourth tiger dot image, and we're going to set this equal to UI image named, and we'll say Siberian tiger dot JPG. Now, if you notice for our tiger instances, we're giving them very specific names. So I'm going to give you extra props if you know what movies these tigers are from or what TV shows. So feel free to post if you know in the comments section. But right now, the idea is that we're able to create multiple tiger instances. And each time we create an instance from our blueprint, it automatically gets these properties. So I know I've said this a couple of times, but this is a really important foundational item. For the reason to create a struct here, a tiger struct, is we were able to encapsulate this information into 4 different instances. And without this struct, it'd be really hard to group all this information together. Maybe you can come up with some really ingenious way to do this without using a struct here. But this is a really cool way now that we're going to be able to reference my tiger.image and get back a specific image, or second tiger.name and get back a specific name. So hopefully you're able to start understanding this idea of encapsulation, or the ability to kind of group information together nicely in a logical way. So this is really the core foundation to object-oriented programming. So it's time to start learning about arrays. Arrays are basically a container in which we can store a single type of instance, and this can include numbers, strings, dogs, like our example in front of you. We just need to remember that it all has to be the same type. So we're going to see an example in just a second where we don't have the same type. Now, we need to also remember that inside of this container, the dogs are ordered. So the first dog that we add to our array is also known as dog at index 0. We use 0 indexing. And this basically means that we can access the first dog by saying, give me the element back at index 0. If we want the last element in our array, and since we started 0, our fifth dog will be element 4, or index 4. We would say, give me back the dog at index 4. Now, arrays are a great way to store information when we have multiple instances of a class or a struct. So in our case, we have multiple tigers going on in our project right now, and later on we're going to figure out how to add all of those different tigers into a container, so we're going to be able to iterate through them. Now, these containers are mutable, which means we can change them. So we're going to be able to add elements to our array as long as they're the right type. We're also going to be able to remove elements. We can remove a specific element. So if we wanted to remove the second dog, or index 1, we could remove an object at a specific index or an instance at a specific index. We're also going to be able to add multiple instances to our array at a single time as well. Now, if you're a little confused what I mean by we're only able to add a certain type to an array, let's take a look at this current slide here. This would not be a valid array. This would cause a break in our code. And that would be if we had 4 dogs, but we tried to add an int or a bool, or maybe we tried to add a string or a double. All these different elements would cause this array to fail because we can only have one type inside of our array at a certain time. In this video, we're going to figure out how to create an array. So we're going to go ahead and create a new playground. And we're going to go to get started with a playground. And we can call this arrays. And this will be on the platform iOS here. So we can go ahead and select next. And I'm just going to create this on my desktop. So the first thing we're going to do is we're going to figure out how to create an empty array. And to do this, we can just write var tiger names. And we can say that this is going to be an array. However, when specifying that a variable named tiger names here is going to be an array, we also have to specify what type will be inside of the array, since we can only have one type of instance inside of an array. So in order to do that, we can specify that this is going to hold strings. And this is the first type of syntax. You won't see this used very frequently, but there will be cases where we'll throw it in just so you're familiar with this in case you see this in code. You'll understand that what we're doing here is we're specifying a variable that's named tiger names. It is an array, and that this array will only hold string instances. Now, another way we can write this, and we're going to use this a little bit more commonly inside of our applications, will be to specify tiger names again. But this time we're going to specify that it's an array that's going to hold strings using our literal syntax here. So what this is going to do is this bracket notation here represents an array, and we're going to be specifying that this array, right, our brackets here, will be holding string instances. So this is a little bit more of a common way to write the same thing that we wrote earlier, that we have a variable named tiger names, it's an array, and it's only going to hold string instances. We can also, and again, I'm just going to comment this out here, create an array named tiger names. And we can immediately specify that this is going to be an array that's going to hold some strings by actually creating the array and adding some variable names to this, or some strings. So we're going to say tigress, and let's add Jacob, and we're going to add spar. Needs to be a string here. So what are we doing here? Well, we have a variable named tiger names, and we don't have to specify the type because we're going to immediately set it equal to an array. So it knows that tiger name should be an array, and it's only going to hold strings. Now the first string, or the first element inside of our array here, will be Tigger. Our second element will be Tigress. Our third will be Jacob, and our fourth will be Spar. And notice that these are all strings. We separate them with commas here, and this separates each instance inside of our array. And we also use our literal syntax here. This bracket represents that this is an array. So it's actually going to create the array. It's the same thing as initializing the array, but we're going to initialize it with 4 strings inside of it. So it knows what type it should have added. And we can do this with other types here. We could say something like tiger ages, and we could set this equal to 3, 2, 4, 5. And let's just make this consistent. And in this case, we're creating an array, tiger ages, and it's an array that holds integers. Notice that we're using numbers instead of strings. And we could also do this with doubles, but we would want to be consistent. Whatever type we add, we only want to add that type to the array. So this is how we can quickly create arrays, and this is also how we can create an array ahead of time if we need to assign it an array value later on. Now let's create another array so we can figure out some cool properties we can access from our array. And the first one we're doing is we're just going to generate an empty array. And we're going to say that this is going to hold string instances. And we're going to set this equal to an empty array. Notice that we set this equal to just an empty array, but we want to specify the type here. Because it's empty, it's not automatically able to figure out what type of instance it should be holding. So we have to specify that it's going to hold string instances. And then we can run an if check here using our control flow. We're going to say if empty array dot is empty. And we're going to say print line. And we'll say there are no elements in my array. And we should see that print out to the right, which we do. We can add an else statement below this, and we could say print line, and we'll say there are elements in this array. Right, so if I were to add a string here, some string, right, we'd see the second statement would evaluate here our else because the empty array is not empty. But if we leave this as empty, we see the first line evaluates because it is in fact empty. So a quick check to see if your array is empty is to just access this property is empty, right? It's an attribute of the array. We can also use the count property, and this is going to be really handy to figure out how many elements are inside of an array. So let's say print line, and we're going to print our print line tiger names dot count. And this will print out 4 for us because we currently have 4 instances inside of our tiger names array. So using this count property, we can figure out how many instances are stored inside of an array. So let's also try this for our empty array. Let's print line, and we'll do empty array dot count, and we're going to see 0 now prints out to our console. So in this case, right, we have no elements added to our empty array. So in this case, when we access the count property, we see that there are 0 elements inside of the empty array. Now we want to figure out how to get different elements out of our arrays. So arrays start off with the 0 index. So basically what that means is the first element inside of an array, so Tigger here, can be found at index 0. And then we go up by 1. So we said that the element at our second place in our array here is at index 1, and spar would be at index 3, right? It's the 4th element in our array, so it's index 3. So the same thing would be for tiger ages, right? 3 would be at index 0, and 5 would be at index 3. Now it's important to remember this because we're going to see this idea of 0 index all over the place. So just really try to remember that the first element in an array is going to be index 0, and we're going to definitely see other use cases where we start at index 0 and we iterate upwards. So how can we actually get the element out of our array? Well, let's just create a constant. We're going to say let first name from array equal, and we can say tiger names, and we're going to use this bracket notation here. And this is going to basically say, okay, go to my tiger names array and grab the element at the specific index, and I'm going to pass in index 0 right now, which is going to say, okay, grab the element or the first element in my tiger names array, and that's Tigger. Now, if I change this, right, if I made this 2, we'd see Jacob, and if I change this to 3, I'd see Spar. Now, we could do the same thing. Let me just change this back to 0 so this makes sense here. We could say let second age in tiger ages array equal, we could say tiger ages. And how do I get my second element? Well, remember that that's index 1. So we'd say index 1, and this would give us 2 back, right? And that's the second element in our tiger ages array. So if you're a little bit confused by this, just try to get each of the elements back from both of our arrays here so you understand the idea of the 0 index. We start at index 0. With that in mind, we also want to figure out, okay, so if I have an array, how could I iterate over my entire array? And one of the most common ways we're going to do this is with a for loop. There's a few different ways we could do this with a for loop. I'm going to show you one right now. We're just going to do the for loop we're familiar with, the for var I is equal to 0. And it makes sense to set I equal to 0 because we're going to want to access the 0 index first, right? And then what are we going to iterate up to? Well, we're going to say I is less than tiger names dot count. So we're going to say, okay, as we go through, let's go all the way up to, but not equal to, the count of the tiger names array. And that's because, let's say our tiger names array holds 4 elements. We don't want to try to index into the 4th index in our tiger names array because that's not valid. We don't have a 5th element here. And this would cause a crash for our computer program. So we only want to go up to, right, the 4th element, which should be index 3. So we're going to do it less than, not less than or equal to. And then we're going to iterate by 1. So we're going to say I++, and we can add our curly braces here. Now that we have this for loop generated, we can just generate the constants here. We can say let instance from array equal tiger names, and we're going to do I here. And this will give me back the instance from our array here. So as I run through my for loop here, I'm going to start at 0 and we'll get Tigger back. And then when I is equal to 1, we'll get Tigress back. When I is 2, we'll get Jacob. And when I is 3, we'll get Spar back. And then we can just print these out to our console here. So we'll do print line, and we'll just pass in the instance from array. And we'll see that this is printing 4 times. So let's go ahead and take a look at our console here and make sure we're seeing all 4 elements. So we see Tigger, Tigress, Jacob, and Spar all printing out to our console here. We have 2 additional for loops that we're going to look at. The first for loop we're going to use to iterate over our array. So what this loop allows us to do is it allows us to access all the elements inside of a given array. But instead of having to use indexes and indexing into the array, we automatically get access to it as a parameter or a variable name here. What do I mean? Well, let's try this out. We're going to write for tiger name in tiger names. We're going to add some curly braces here. And let me just add some returns after this so I can kind of center it up nicely. We're going to be able to gain access to each one of the elements in our tiger names array. Remember, this is an array of strings. And as it iterates over the array, it's going to grab each instance from our array and it's going to assign it to tiger name. What do I mean by this? Well, let's just go ahead and print out tiger name here. And we're going to see it's going to print out 4 times here. And we should see, we can actually even quickly comment out our previous for loop here, just so we are not confused. Let's go ahead and take a look at this in the console here. And we're going to see all 4 of our tiger names print out. So if we go back here, essentially what we're doing is we're using the keyword for, and we're using this keyword in. So it's for in. We call this a for in loop. And we're basically saying, okay, for some sort of variable name in some array, iterate over the array, grab each instance, and as you grab an instance, go through the curly braces and assign it to the variable name tiger name. So as it goes out, it pulls out the first instance from our array and assigns it to tiger name. And it says, okay, well, that's Tigger. And it keeps going through. And each time it runs through the for loop, it grabs the next instance in the array and assigns it to this variable name tiger name. So these 2 types of for loops allow us to either make sure that we're hitting everything in our array and we don't have to worry about any indexes, or if for some reason we want the index, maybe that we're going to do something else with that number and it's nice to have access to that number. Our original example of the for loop here gave us access to it, but we had to then index into the array manually, which was an additional step. The final thing we want to take a look here is using a for loop. So we're going to say for int tiger number, and this is just a random variable name I'm coming up with here, in 1.3, and let's just print line, and we'll print out tiger number. So this variable name is just completely random. We could make this X if we wanted to. That's completely fine. As well, we would just print out X if we did that way. And what this is going to do is it's going to assign the value of 1 to X, and it's going to run through this for loop. And then it's going to go to 2 and all the way through 3. So it'll go 1, 2, 3. So if we made this 5, for example, X would start at 1 and it would go all the way through. So let's take a look. We can take a look at this in the console. We see 1, 2, 3, 4, 5 is now printing. So this is a different type of for loop. That's a pretty cool way that we can print out numbers in a certain range. And this is what this triple dot here is. It's a range in between two numbers. So we're doing 1 through 5. And we see that each of these values gets assigned to X, and we have a for loop here. So this is not useful for iterating through an array here. We're just showing you a different type of for loop, which is going to allow you to print out numbers in consecutive order. So our first two examples allowed us to access an array, and our new example is just showing us how we can iterate over a number. And this is a little bit different from the original for loop we saw. So if you see this ... it's a range. So I just want you to be aware that this range exists. So I want to show you one final type of for loop, and this is going to be the for in enumerate loop. And it kind of combines these first two examples we had here of our for loop so that we can both do a for in but also get access to the index. Let's just jump right into this. I'm going to scroll to the bottom here, and we're going to write for index, comma, tiger name, and we're going to do in enumerate, and we're going to pass in tiger names, and we're going to add some curly braces. What's going on here? Well, we have three keywords we're using here. We're going to use for in, and then we're going to use this enumerate, and this takes a parameter of our tiger names. We also have to add two parameters here. This is going to be our ability to access what index we're on, and this is going to be the variable name of the instance we're accessing from our array. So let's just print this out and take a look at what's going on here when we actually run this. Let's do index colon, and we'll pass in our index. And then we're going to do tiger name colon, and we'll pass in our tiger name. And let's go ahead and just take a look at this in our console here. So we're going to see index 0, tiger name is Tigger, index 1 is Tigress, index 2 is Jacob, and index 3 is Spar. So that means that we're accessing all of the elements inside of our array of tiger names. So we can see that it kind of works like our first for loop here, and that we get the access to the index, where before we had I is equal to 0. So it's a little bit easier to set up. All we have to do is this index and enumerate, and then we don't actually have to index into the array manually, right? It's automatically going to do that using the style of our for in loop, where it automatically assigned each instance as it iterated or looped through our for loop to the tiger name variable. So this is a pretty cool way we can use for in when we also need the index, right? So we're still not forced to manually access tiger names ourselves. So this is a really new addition to Swift. It's really cool, and we'll definitely try to squeeze this into some future projects. But for now, we're also seeing some redundancy here, and simply being able to iterate over an array and understanding that sometimes you want to access each element inside of an array is really common in computer programming languages. So there's a bunch of different ways you can do that, and you don't always have to use the most optimal way. As long as you can do that initially, then you can do some refactoring and figure out, okay, well, maybe in this case, for in enumerate would look a little bit nicer, or maybe I don't need the index, so I can just use a regular for in loop as well. In this video, we're going to learn about array mutability, specifically the ability to change our array once we create it. So far, all we've learned how to do was to generate an array and then how to iterate over the array. So let's get started. We're going to create a new playground project, and we're going to choose to name this array mutability. And let's go ahead and select next and create, and we can enlarge our project here. And the first thing we'll do is we'll create an array, and this array will have two strings in it. So we're going to say var tiger names, and we're going to set this equal to Tigger, comma Tigress. And we want to figure out how to add a single instance to our array. Specifically, we want to add a single string to our array. In order to do this, we're going to use a function called append. And the function append takes one parameter, which is the instance we want to add to our array. We also want to make sure that when we're appending instances that it's of the same type as the instances we already have in our array. So in this case, we could only add a string to the tiger names array. So how do we do this? Well, we're going to type in tiger names, and we're going to call a function here. So we'll use our dot notation, and the function's name is append, and it takes a single parameter, and that's a string. So we'll pass in Jacob, and let's go ahead and just print out our current tiger names array here to see that it has 3 elements in it now. We can just print line tiger names, and we see Tigger, Tigress, and Jacob is now in the array. So our array now has 3 elements because we appended the Jacob string. It's also possible to add multiple instances in one time. So we can do that with a little bit of shorthand here. We can say tiger names plus equals, and we'll do John, Elliot. And let's once again go ahead and just print out our tiger names array here so we can see the changes. And we'll see Tigger, Tigress, Jacob, John, and Elliot. So this is just a little bit of shorthand here. This plus equals, and we're going to say, okay, add an additional array to this, and this array has 2 elements. Notice that they're both strings because we can only have strings right now in this tiger names array. So we're saying tiger names should add this new array, and we're going to have multiple elements in here. So we can use this shorthand of plus equals to add multiple elements at a single time. We can also replace an instance inside of an array. What happens if we don't like having Tigress in here anymore? We want to remove Tigress and replace it with Spar. Well, we can do tiger names, and we're going to index into this. We want Tigress. So remember, that's equal to index 1 because Tigger is at index 0. And we're going to set this equal to Spar. Notice that I'm using a string again because our tiger names array can only hold strings inside of it. And then let's print line, and we'll print our tiger names array out again. So we see that Tigress has been replaced with Spar, but all the other elements inside of our array are still consistent. So we indexed into our tiger names array. We indexed into index 1, which is the second element, and setting that equal to a different value updated our array with the new value. We can also replace multiple instances at a time using a range operator, and we saw the range operator when we did our for loops. And the way this works is we're going to be able to say tiger names. We're going to do 0.2, which says that will be replacing elements starting at index 0 and going through to, excuse me, I'm missing a dot. And it's ... 3 dots, 2. So 0 through 2. And that means we need to set this equal to an array with 3 elements. So let's pass in Katie, James, George. And then let's go ahead and print out our tiger names array again. And we should see 5 elements, and notice that we've completely replaced our tiger names. And now it says Katie, James, George, John, and Elliot because we replaced elements 0 through 2 with our new array. So we replaced Tigger, Spar, and Jacob with Katie, James, and George. So we were able to do this range operator ... 0 through 2. Another cool ability for array mutability is the ability to insert an instance at a specific index, right? So let's say we don't want to just add it on the end, which is what append does. We want to put it in at a specific index. Let's say we want to put it in right after Katie, but right before James. Let's insert another name. So we can say tiger names dot insert, and this takes 2 parameters. The first is the element we want to insert. So let's insert Julie, and let's insert her at index 1. And then we can do print line, and we'll print out our tiger names. And we'll see Katie, Julie, James, George, John, and Elliot. So now our array has 6 elements, but we didn't add it at the end like we did with append. We inserted Julie at a specific index by passing in 2 parameters. Notice that once again, Julie is a string because tiger names can only have strings inside of it. I keep repeating that because it's very important. If you're coming from Objective-C, you were able to add many different types of instances into an array, and that was completely valid. that's not valid in Swift. So we have a few more functions to get through. I highly recommend that as you're going through this, you take a little time, make a new playground. Maybe you try this with numbers instead of strings if you're a little bit confused. Just get used to these functions, get used to this shorthand. We're going to be using this in our upcoming projects. So if you're brand new to computer programming, make sure you understand how to play with arrays, because we're going to be using arrays quite a bit in the future. It's a really common instance type. So the next thing we want to figure out how to do is how to remove some instances from our array. And we're going to do the opposite of append, which adds an instance at the end. How do we remove an instance at the end? So let's do tiger names dot remove last. And let's go ahead and print out our tiger names array. So now we can see that our tiger names array no longer has Elliot in it. Our function remove last removed the string Elliot. And now our tiger names array has Katie, Julie, James, George, and John inside of it. We can also remove instances at a specific index, which is the opposite of adding at a specific index or inserting, right? So we had insert Julie at a specific index. We can remove at a specific index. So we're going to do tiger names dot remove at index. And we can say remove at index 1, which should remove Julie in this case, right? Notice this is at index 1. And then we can reprint out our tiger names array. And we're going to see that it has Katie, James, George, and John left inside of it. And what happens if we want to just completely wipe this thing clean and start over? We don't want anything in our tiger names array. Well, we can say tiger names, and we're going to do dot remove all. And it's going to ask us whether or not we want to keep the capacity. And this is basically saying, do you want to save this memory that we've allocated for this array because you're going to be adding roughly the same amount of stuff in the future? Or do you want us to just free up this memory for future use? Maybe you have some different things you're going to do. And in this case, we don't need to save this memory. We're not going to be re-adding elements to the tiger names array to make it roughly the same size. But there will be a use case we'll see in the future where we're going to set this to true, because we're just going to keep clearing the array and re-adding the same amount of elements to the array over and over again. So if that's kind of your use case, you want to set this to true. But if you're not going to re-add elements to the array, or if you're not sure, just might as well clear up the memory so it can be reused by the computer program effectively. So you can just set that to false. And then we can do print line, and let's pass in tiger names. And we should see that our array is now empty, which is the case down here. So once again, we've had quite a few different functions here. I know this has been quite a bit. We have a few more things to go over in our coming lectures, and then we'll jump back to our Lions and Tigers project and start implementing these things. But once again, if you're confused, if this is kind of really new to you, I highly recommend you go back, you play with this, try to do it yourself. Maybe write down some of these functions, just at least understand what's going on with this syntax. And you could try this once again with numbers instead of with strings, and that'd be a good way to practice this on your own. Now we want to figure out how to generate a random number. And in order to do that, we're going to once again open up a new playground project. And so we're going to get started with the playground. And we're going to call this generating a random number. And we're going to use iOS as the platform. We can go ahead and select next. And let's just generate this on our desktop. And the first thing we're going to do here is we're going to write a bit of code here, and then I'm going to go over it. We only really have to add one line of code here, so there's a ton to remember here. But this code is going to seem a little bit scary until I explain it. So we're going to say let random number equal, and we're going to say int. We're going to do arc for random underscore uniform. Sorry, I've used that autocomplete here. We want arc for random underscore uniform. Very important that we get the syntax and these parentheses correct here, otherwise it won't work. And then we're going to do uint 32, and we're going to do another parenthesis here. We're going to pass in 5, and then we need 3 parentheses at the end here. So just make sure your parentheses line up. Take a second, make sure your code looks the same way, or copy and paste it from the notes section if you are having trouble entering this in properly. And
we see that its value is 2 over here. So this is a really cool way we can generate random numbers. We're going to be using random numbers a lot in our coming applications because it's going to allow some sort of dynamic UI where we're able to randomly generate things. We're going to be, in fact, building a slot machine game where we definitely need random numbers because we need to randomize the results from our slot machine. So in this case here, we're saying that we're going to make a constant and its name is going to be random number. Hopefully that seems pretty clear. And we're going to set this equal to int. And remember that this is just our numeric type conversion where anything we enter inside of these parentheses will be converted to an integer, right? So we're actually using some special syntax here for an unsigned integer, 32-bit. And, we don't want any special type of integer back. We just want the default Swift integer. So we're going to use numeric type conversion here to confirm that this is just a regular integer that we know how to use. And inside of this, we're going to say arg4random_uniform. And this is a special bit of functionality that we have here that accepts one parameter, and that's going to be an unsigned integer, 32. And we're going to pass in another value. We can just pass in a number here. And in this case, we're going to pass in 5. And what this will do is it'll generate a random number between 0 through 4. So it's going to give us 5 different options, but it starts at 0. So it's going to 0, 1, 2, 3, and 4, which is 5 different options. So if we made this 10, it would generate 0 through 10. So this is a really cool way that we can generate a random number. This bit of syntax might seem a bit scary, but in this case, if we ever need to generate a random number, I highly recommend you just come back here and you just copy and paste this code. There's no real reason to memorize this code. You just need to know that there's this bit of code that we can use to generate a random number. And you need to remember that by changing this parameter here, we can determine what the range of random numbers that can be generated are. And that you need to remember that it starts from 0 and it goes through the value of whatever this number is minus 1. So if this is 5, it's going to go 0 through 4. If it's 10, it's 0 through 9. If it's 20, it's 0 through 19. So if you can remember those two things and just remember to copy and paste this code, you're good to go. We're going to be generating quite a few random numbers in the future. So you're going to see this syntax used quite a few times, and it should become pretty second nature. But for now, we just need to understand that we're able to generate random numbers kind of using this super funky syntax. And with this, we're going to be able to make some pretty awesome applications in the future. Now let's go back to our lions and tigers project. You can either open this from your right-hand panel here when you have Xcode open, or you can go ahead and open up your project. I have mine saved on the desktop and just double click on lionsandtigers.xc project here. So in this case, we want to create a property that's going to be used to store our tiger instances. And the reason we're going to use a property is our property is going to be accessible in all of our functions here. We're going to be able to access it in both this IV action, next bar button item pressed function, as well as view did load. So that's going to be the idea behind using a property to store this information. The property is going to be of type array, and the array is going to store tiger instances. Let's see how we can do this. The first thing we're going to do is we're going to add a bit of code here. I'm going to say var my tigers. And notice that we're using a plural here. Plurals indicate that this is probably an array. And we're going to specify that this is going to hold tiger instances. And we're going to set this equal to an empty array. And it's really nice to set this equal to an empty array because we know that this array exists. So if we start trying to add elements to it, it will work, right? We have an array that we can add elements to. Now, if we just made this an optional, right, there would be a chance that it wasn't created yet. We would still be able to call functions on myTigers, the variable name, and we would be able to say myTigers.append, but we'd be appending it to an array that did not exist. So it's important that we add this equals an empty array because now the array exists. That's what we're doing. We're saying, okay, an empty array now exists. Now we can actually add things to the array, whereas if we try to add things to an array that does not exist, we won't get an error in our code, but nothing will happen. All right, so this is why it's so cool to do this. Now, our property here, right, unlike our tiger struct when we added properties because we wanted to encapsulate information, in this case, our property is going to allow us to access the mytigers array in multiple functions. Let's first set up the mytigers array to add some additional elements, and then I'll show you the idea of scope, or the idea that mytigers, the variable name, is accessible in multiple functions. So we can say here that we want to append the mytiger instance. We could say mytigers, our array, dot append, and let's add the mytiger instance here. And we see that now we're able to add a mytiger instance, or the tiger instance here, to my mytigers array, because we're specifying that the mytigers array holds a bunch of tiger instances. We can also use our shorthand that we learned about to add multiple instances. Specifically, we're going to add our second, third, and fourth tiger instances to the mytigers array. So we'll type mytigers plus equals, and we'll do second tiger, comma, third tiger, comma, fourth tiger. And what this will do is it's our shorthand to add multiple instances at a time. And we're going to say we want to add to the mytigers array the second, third, and fourth instances of the tiger struct that we created to the mytigers array. So now we have all four of our tiger instances inside of the mytigers array. Now, we're not going to use the mytigers array just yet. We're going to show you how to do that in just a second. But I wanted to quickly touch on the idea of scope, and that's the reason we created the mytigers array as a property. Instead of just saying something like, var tigers, and we could have specified that this was an array that held tiger instances, and we could have set this equal to an array that held mytiger, right? And actually, so we won't use a lowercase here. We would have said like tigers. Instead of making this a local variable, right, and this local variable is only accessible inside of viewDidLoad, we made this a property, and we initialized it ahead of time up here. And now the mytigers variable name is accessible in next bar button item press. We can start typing mytigers, and we could even do a print line statement of this if we wanted to. So let's just quickly do mytigers. And let's go ahead and run our application here to show that because viewDidLoad, the function is going to be called first, it's going to go ahead and set up the mytigers array. And then when we press our button, we're going to be able to actually print out the mytigers array. So this property is accessible in both functions. So let's go ahead and press next. And we can see that our array prints out here, and it's printing out 4 different tiger instances, and it's showing it inside of an array here. So our array, in fact, has 4 elements in it. So this array was properly set up. Whereas like mytiger, the local variable, is not accessible here, right? So if we try to type in mytiger, right, we're going to get an error here. And it's going to say use of unresolved identifier mytiger. And that's because this is not a property. This is a local variable that we're defining, whereas our property is accessible in multiple functions. So we've seen 2 use cases once again for a property. The first time was to encapsulate information so that each time we created a tiger instance, we automatically had access to name, breed, age, and image. And now we're seeing the idea of scope, or the idea that properties are accessible in all of the functions inside of a single class, right? So we're inside of the view controller, and the mytigers property is accessible in all of these functions. So it would also be accessible in did receive memory warning. We wouldn't have a good use case to actually access the mytigers property here, but we will have a good use case to access it in the next bar button item pressed function later in our next lecture. Now that we have our tigers stored in the mytigers array, let's figure out how to display a random tiger on the screen. So we're going to go into the next bar button item pressed function. We can go ahead and remove this print line. And the first thing we're going to do is we're going to generate a random index. And this is going to be based on the number of tigers in the tigers array, or the mytigers array. Right now that's 4, but let's make that dynamic based upon the number of tiger instances in the mytigers array in case we were to change this in the future. So in order to generate a random number, let's say let random index equal, and we'll do int, and we're going to do arg for random underscore uniform, and we need to pass in an unsigned 32-bit integer. So we'll just pass in mytigers.count. And we'll add the correct number of parentheses. And this way, the number of random numbers coming back is going to be based on the count of the mytigers array, specifically the number of instances of tiger inside of the mytigers array. So with this, we'll be able to index into our array. So we can say let tiger equal mytigers, and we'll pass in our random index. So we can see here how these two are connected. The random number we're going to generate using our random generator here that we learned about earlier, the arc for random underscore uniform, is going to be based upon the total elements in our mytigers array. And then when we get a random number back based upon that, we're going to be able to index into the mytigers array to get back a specific tiger instance, and we can set that equal to the constant named tiger. Then we can go ahead and update our UI based upon this tiger that we got back here, and we can say my image view dot image is equal to tiger lowercase dot image, and we can update the name label. So we're going to say name label dot text, and we'll set this equal to tiger dot name, and then we can do age label dot text. So we're going to set this equal to, we'll do some string interpolation here. So we're going to say tiger dot age, and finally one extra quote there we can remove, and then we're going to update our breed label dot text. Is this going to be equal to tiger dot breed? So we're updating the UI the same way we did in view data load, but this time we're getting a random tiger instance back from the mytigers array using arc for random, so we can generate a random index. So let's go ahead and run our project here and see if this actually works now. And let's press next. And we're going to see sometimes it doesn't update because it's generating the same random index that we're already displaying on the screen. But for the most part, we're able to get back new tigers each time we press the next button. So in this video, we're going to learn how we can have a nice transition occur between our tigers. So when we load a new image on our screen, we're going to get a different transition of our views. What I will say though, before we get started on this, is we're going to use a bit of advanced code. We're going to use something called a closure. And they're not super scary, but it's a really different syntax than everything we're seeing. And we don't want to heavily introduce closures just yet. We're not going to get into how to create closures yet, which is usually what we do when we introduce a new concept. Usually we go into Playground, play around with it, really understand what we're doing, and then we're going to jump over. In this case, we're going to just use this code. I'm going to walk you through the process. I'm going to explain how this thing works. We're going to fill out the parameters, but we're not going to get into how to build a closure ourselves. And the reason for that is because this is a bit more complicated. We want to still focus on some fundamentals before we get to that. So later on, specifically in our TaskIt project, we'll see an example of a very basic closure. And then even further after that, we're going to start building and using more advanced closures. So we're really just going to push this to the side. One of the ideas you should get out of this, or using a bit of advanced code, is it's okay to use some advanced code sometimes. As long as you can get things to work, it's really nice to understand how everything works, but sometimes it's just out of the scope of what you're ready for. And as a new developer, you sometimes need to be comfortable with being uncomfortable. And hopefully this one little bit of code doesn't throw everything out of orbit as you're working through this stuff. So we're going to work through this together. You're going to get a really cool functionality out of this, but we're not going to fully understand closures yet. So that's my explanation on why we're not going to get heavily into closures just yet. So the first thing we're going to do here is we're going to go ahead and we're going to say UI view dot transition with view. And we're going to make sure we choose this autofill option here. It's really important that we don't just type out in this whole thing ourselves, because there's a lot of chances to make mistakes if we don't use the autofill. So you're going to find this, you're going to just use the arrow keys, and this should auto-populate for you. And then you can press the return key here. We're going to be very careful because it's really easy to break this bit of code here. So we have to fill in a bunch of parameters here. And we see that our first parameter is currently highlighted here. And when this thing is highlighted, we're going to be able to just start typing and it's going to override this parameter. Now, if for some reason you mess this up and it just fills in like that and you start typing, you're going to want to delete this code up to the comma. So we're going to do self.view, and it's basically asking here for the first parameter, okay, which view am I going to be animating? And we're going to be animating basically this entire view that's currently in our view controller. And we automatically get access to this view property from self, and we're going to talk more about self in the future. But we're going to be able to basically access this view by saying self.view. And self, if you're curious, is just basically the current instance of the view controller that's showing on the screen. Again, self can be really confusing. So once again, this is a bit of advanced code, but very shortly we're going to be getting into self, when to use self, and exactly what self means. The next parameter we're going to use here, so we can actually just press the tab key to get over to the next parameter here, is going to be the duration. And this parameter is going to specify how long the duration should be for the animation. So right now, let's just set that to 2. And our third parameter here is going to be the options, or our UI view animation options. And basically we can specify what type of animation we want to have occur. So we're just going to use kind of a default here. We're going to do UI view animations options, UI view animation options. And we're going to do dot transition cross dissolve. And this is going to give us a nice cross dissolve transition between our animations here. So we're finally going to select this option here. And basically what we're going to do is we're going to highlight this and we're going to press the delete key and add curly braces going to the left and right. It should automatically add the right one here. And we're actually going to do the same thing for our completion here, but we're going to add just a bit of code here. We're going to delete this. We're going to add some curly braces. And then we're going to type in here finished, and then we're going to do bool, like that. And then we're going to do dash angle bracket, and we'll do parentheses in. And that will be the final bit we write here. So just make sure that you deleted the previous, and then you added this bit of code here that we just wrote. So hopefully that wasn't too confusing. Again, we're not going to get heavily into what this code is doing, but I will explain what's going on in terms of the completion block. We had to pass in a bunch of parameters, and now inside of this set of curly braces, we're going to be able to specify what animations we want to happen. And then down here, we could add a bit of code that would happen after our completion of our transition, but we're not going to need to do anything with that. So we're going to be able to leave this just blank for now, but we are required to put this code in here. So again, this will make a lot more sense in the future once you understand how closures work. For now, just this is the code you need to get in there. So just really pay attention to the syntax in here. If you're having trouble with this, you can always go ahead and copy and paste the code in that we're going to have in the code snippet as well. I know this is a bit confusing. But what I do want to show you is how cool it is that we can add some animations here. So we're going to just quickly comment out our previous bit of code here. And you can just leave this comment out here so you can kind of compare the two ways we're updating this. Now, when accessing properties, we have a bunch of properties here. Even though IB outlets have this special keyword in the weak, they are still properties. And we mentioned that the My Tigers property, it was accessible in all of our functions. So we know that these properties, my image view, name label, age label, and breed label, are accessible in all of our functions. We can access properties directly the way we've done here by saying things like My Tigers, My Image View. We can also access them the same way using the self keyword, but self is very explicit that we're accessing a property, whereas just typing the name here could conflict with a local variable, right? So My Tiger, the only reason we know it's a local variable is we see it up here is var My Tiger, right? And we see that the color is different. But with the properties here, we could also access them with the self keyword. So we are actually required to access them with the self keyword inside of this animation here. And we're going to say self.myImageView.image is equal to tiger.image. And we're going to say self.nameLabel.text is equal to tiger.name. and self.agelabel.text is equal to, and we'll do our string interpolation here. We'll say tiger.age. And finally, we'll update our breed label. So we'll say self.breedlabel.text is equal to tiger.breed. Wow, that looks super different, right? But it's actually fairly similar. The only thing we're doing is we're accessing the properties with the self keyword instead of just accessing the name directly. And self can be very confusing, I understand that. But we're going to have a whole lecture devoted to this in about 10 lectures or so when we fully go over the self keyword. So please just stick with me right now. This is a pretty advanced video, I realize, but I really want to show you guys how these animations can work. So right now, we're going to go ahead and run our application. And let's press next. And we're going to see we get this nice cross dissolve that occurs here between our images. So that's a direct result of having added this code here. And once again, part of becoming an awesome developer is at first becoming a little bit uncomfortable with bits of code and then slowly integrating and figuring out exactly what's going on with some time. So that's exactly what we're going to do here. We're going to absolutely come back to the self keyword pretty soon. And then later on, we're going to absolutely come back to closures. So this code will all make sense by the end of this course. But for now, I'm just asking that you take a little bit of a leap of faith and just add this code, and you get this really cool functionality as a result. So it's a really great way to introduce this, although we're not going to be able to get into everything in this lecture. We're going to take a little bit of a break from our Lions and Tigers project again to learn a new bit of code, and this will be a lot easier than that closure and that self keyword we saw last lecture. So we're going to go ahead and open up a new playground, and we're going to get started with a playground here, and we're going to call this while loops. And this is going to be on the iOS platform. And let's go to our desktop and we're going to press create here. So let's go ahead and enlarge our project. And while loops are pretty cool. While loops will run or spin infinitely, we can say, until a comparison fails. So they can also be a little bit dangerous because if our comparison number fails, it'll just spin infinitely and just eat memory, and that's no good either. So we need to be a little bit careful with while loops. We'll see how to create one in just a second. But we're also going to be introducing do while loops, which is a slightly different variation of the while loop. So let's get started. The first thing we're going to do is we're going to create a variable, and we're going to say this variable's name is x, and its value will be 5. Then we're going to create a while loop here, and we're going to say while, which is the while keyword. Then we have to do some sort of comparison on our variable here. So we're going to say, well, x is less than 10. And we can do print line, and we'll print the value of x. And then we'll do x plus plus. So it needs to be next to it. So what are we doing here? Well, we use our while keyword, and we have a comparison here. We say, well, x is less than 10. And we're just going to print out the value of x here each time it spins through the while loop. But notice that we also add x plus plus in here, which is a way to make our comparison fail at some point, because eventually the value of x will become equal to or greater than 10, right? In which case this while loop would no longer evaluate, right? As soon as x is equal to 10, this while loop would terminate and we would be able to continue running our code below it. So let's quickly take a look at the plus here. We can see that it starts at 5, it goes to 6, 7, 8, 9, and it stops right before it gets to 10. So our while loop is working properly. But we could see the danger here, right? If we were to comment x plus plus, we see that this just runs infinitely, right? So it's super dangerous. Always make sure that when using a while loop, you have some way to terminate it. And we can see that my computer program, it's already spinning on the screen. It's already about to crash. So need to be super, super careful here. The next thing I want to show you is a do while loop, which is an alternative way to run a while loop. And essentially what we're going to do is we're going to say do some functionality while a comparison is true, and as soon as the comparison is false, you no longer need to do this functionality. So let's go down to the bottom here. We're going to write do, and let's just create a variable actually right ahead of time. We're going to say var y is equal to 10, and we can say print line, and we'll just print out the value of y, and we'll increment y. So we'll say y minus minus, And we can add a while test at the bottom here. We can say, well, y is greater than 0. So we can see here that this is going to run 10 times. And let's just go ahead and check out the values here. We'll see that it starts at 10, which is our initial value of y, and it goes all the way down to 1. And as soon as y is equal to 0, it terminates the do loop. So this is just another way that we can write the same functionality as our while loop. Sometimes it just sounds a little bit nicer. Also, it's just kind of preference for the developer. So these are the two ways we can use our while loops that we're going to be using mainly as we write our Swift code together. So let's go ahead and open up our Lions and Tigers project. I've just opened up my folder again. We're going to reopen this project. Sorry for opening and closing so many times, but I like to show you guys things in Playground and then come back and show you it in a real project. Kind of gives it a little more context, I feel. So we're going to go ahead and make a little adjustment here. Right now we got a little bit of a bug. And right now, when we press the next bar button item pressed button inside of our application, sometimes we see the same tiger twice. And we want to fix that. We want to make sure that we're seeing a new tiger every time we press our button. So that comes down to our random index here. We're going to want to update this. And the first thing we're going to do is we're going to want to make our random index a property. And this is going to kind of be the third major reason to use a property. The first one was encapsulation for our struct. The second reason was to have accessibility in multiple functions. And the third reason we're going to see here is the ability to save or persist a piece of information through the lifecycle of a class, specifically inside of our view controller, right? As long as this view controller is being presented on the screen, and usually even farther along than that, right? Assuming we don't dismiss this view controller, and this is our first view controller, so it will remain in memory for the life cycle of our application. We're going to have access to a value that we set as a property. What do I mean? Well, let's go ahead and we're going to go to the top here. We're going to add an additional property, and we're going to say that this is going to be var current index, and we're going to set its initial value equal to 0. And the reason this will work so nicely is because the first element we're going to display on our view is going to be the first tiger instance in the my tigers array, specifically the instance name my tiger here. So now we can go down and we're going to see the idea of persistence between each time we press the next bar button item pressed IB action, or each time we call the function next bar button item pressed. And we're going to be able to use a do while loop in order to update the current index so it's not the same as the random index we're generating. So the first thing we're going to do is we'll say var random index, and we'll specify that this is going to be an integer because we'll assign this value later. And we're going to say do, and we'll say, well, we can actually even just grab our code down here. So let's just cut this and we'll drag this up here. And we can remove the let keyword. And then we'll add well below this, and we'll say, well, current index equals random index. Finally, we'll update the current index to be equal to the random index. So we'll say current index equals random index. All right, let me explain this code. The first thing we're doing is we're creating a variable, and its name is random index, and we're specifying that it's going to be an integer, but we're not assigning it a value yet. We're going to assign it a value in the do loop. So the do loop will run once, and it'll assign it a value to the random index. And a do while the do always runs at least once, and then the while loop tests it. If this is true, it's going to go ahead and rerun this do loop until it's false, and then it will terminate this while loop. So it's going to go here, it's going to assign a random index a value, and then it's going to test, okay, is the random index that was just generated the same as the current index? Now we specified the first value for our current index is going to be equal to 0. So if the number that's generated is 0 the first time we press the next bar button item pressed button, and specifically this function evaluates, we're going to test to see, is the random index that was generated equal to 0? If it is, go ahead and run this again. And we're going to keep running this loop here until random index is different than the current index, or the first time we run this until it's not equal to 0. When we have a different value for random index, we're going to go ahead and update the value of current index, right? So let's say it generates 2 the second time. Well, we'll update the value of current index to be 2. Then we'll go down here, we'll say, okay, now that we have a new value for random index, right, that isn't the same as the current index, go ahead and index into the myTigers array and grab a tiger that isn't the same as the current one being displayed. Now, next time we press this button, right, the next bar button item, next time we press this and this function is called, well, what's going to happen here? Well, the value of current index will be persisted, right? We won't have to start from scratch here because it's a property. This value will be saved in between each time we press this button. Now, there could be an exception here if we were transitioning to another view and we're coming back. This would actually still be the case, but if this was, say, the second or third view controller in a view controller stack, let's say there were a bunch of other views we were showing off before this, well, then in that case, maybe this value wouldn't be persisted. But for now, in order to understand the idea that properties can persist some information, we're going to understand just for now that the current index is going to be saved, right? The value is going to be saved in between each time this function is called. And that's really the power of properties. This is another reason to use properties. This is a very specific use case. And we're going to be able to update our tiger being displayed to be a new tiger. Hopefully that's pretty clear. If not, we're going to have lots of chances to use properties for this specific reason. So we're always going to be getting back a new instance of our tiger here. So let's go ahead and run our application and prove that this actually works. So let's go ahead and press next. We see it's updating to a new one, updating to a new one, and so on and so forth. And we can do this until eternity. We'll never see the same one appear twice, right? Because our computer program is in fact working the way it should be. It's time to learn about functions. Functions can be a little difficult to understand when you're first starting out, but we're going to go over a bunch of examples together, and we're going to see that we can customize functions to really meet our needs. Functions are going to save us a ton of time because it's going to essentially be a bit of code that's going to run, and it'll do some logic. It can return a value. We can pass in some information. We'll see all these variations in the future, but we have seen some functions before. We've seen functions like resign first responder, which made the keyboard go away when we called that on our text field. And Apple's written a bunch of functions for us ahead of time so we don't have to create all these things ourselves. So let's go ahead and we're going to open up a new playground here, get started with a playground. And we're going to go ahead and just call this functions. We can go ahead and select next and create. We can enlarge this. And to show you the idea that a function creates some reusable bit of code, we're going to create a very basic function. And we're going to say func print hello world. And let's go ahead and add some parentheses at the end here and a set of curly braces. And inside of here, we can add 2 print statements. Let's print line, and we can do our standard hello world. But you might say, okay, well, when we're reusing this, why can't I just copy and paste hello world over and over again? Well, let's add a second print line statement to really drive this idea home. We're going to add print line, and we'll say hello class. And then we can call this function or have the bits of code that we've added in between these curly braces run every time we call it. So let's call this a few times. We're going to print hello world. Let's print hello world again, and let's do this a third time. So we can go over here and press on this little white circle, and we're going to see hello world, hello class, hello world, hello class, and then hello world, hello class. And the reason this is printing out 6 times, where we have 6 print statements here, we've added 2 print statements inside of the function print hello world, and then we've called this function 3 different times. So each time we call this function, it runs the code inside of these curly braces. So we can see that this is a really quick way in which we can have bits of functionality run without having to copy and paste print hello world, hello class over and over and over again. All we have to do is just call this function, and both of these print statements will evaluate. So at its core, a function is basically some functionality that's going to run when we call it. Now, let's just quickly go over our syntax here so that we see this in the future. It's a little bit easier to understand. We first have this func keyword to specify that this is going to be a function. And then we have the name of the function here. In this case, it's going to be print hello world. And then we're going to have a pair of parentheses. Now, later on, when we add parameters to a function, we're going to put the parameters inside of this. Right now, we have no parameters, so we just have an empty set of parentheses here. And notice when we call this function, right, we use the name of our function and we have our parentheses here. And if we had required parameters, we would pass them into these parentheses at that point. We also declare what the body of our function is going to be here by adding our curly braces, and everything inside of our curly braces runs when we call this function. So this is how we call the function. This is how we define it. So in this video, we want to figure out how to add a parameter to a function. And parameters allow us to make a dynamic function where we can pass in a parameter and have something evaluate differently based upon that parameter or gain access to that parameter. What do I mean? Well, consider an example where maybe we had a function named bark and we passed in a parameter a number of times. We could make bark happen once or 20 times based upon the number we passed in. So let's go ahead and just delete these print hello world function calls here. And we're going to add a brand new function. And this is going to be func print number supplied. And we're going to use a parameter here. We're going to do number :int. And then we're going to add our curly braces. Now, hopefully this looks very similar to the function we created before. There's a reason for that, right? We only want to introduce one additional step. So the difference here is we have a parameter and we put that inside of our parentheses here. So the parameter's name is number. We're going to be able to access number inside of our curly braces here. And this :int specifies that the parameter that needs to be passed in is an integer, right? The only type we can pass in is an integer here. So let's go ahead and print this out. We can say print line, and we'll put in quotes. So we'll do, and the number is, and we'll pass in our number here using string interpolation. Now notice that we're able to access number, which is the parameter name what we have here, right? So this is accessible inside of these curly braces. And we know that number is going to be an integer because we're specifying that here. We can also say something like print line, and we can say the number times 3 is, and we can do number times 3. And this is completely valid because we are passing in an integer, and integers can be multiplied by other integers, right? So we're going to be able to see that, you know, if we pass in 3 here, we'll say the number times 3 is, and we'll be able to display 9. We can also, you know, update a variable. So we can say var number times 2 equals number times 2. That's completely valid. And we could also shorten this if we wanted to using our shorthand. So we could say number times 2 times equals 2. All right, so we can also do an operation after we pass this in and, you know, set this equal to some value here. So we have access to number. It is an integer, and we can do different operations on that. So let's go ahead and just call this function. We can say print number supplied, and you can put any number you want in here. I'm just going to pass in 3 for now. And we're going to see the number is 3, or we should have had is. So we can add is here. The number is 3. The number times 3 is 9. And then we're able to see that when we pass in 3 here, 3 times 2 is 6. So that's the value of our variable displayed here. And then we can manipulate this. So we can say 6 times equals 2 is 6, you know, is number times 2. We're going to update this value. We're going to set this equal to number times 2 times 2, right, which is 12. So by adding this parameter, we can change the values inside of the print number supplied function by changing this. So if we change this to 4, we're going to see the number is 4. The number times 3 is 12. We're going to see 8 and then 16. So parameters just basically allow us to dynamically pass in some sort of information, and then our function can access that information by accessing the parameter name here, and then do whatever it wants with it, or whatever we specify, being that we're the developer writing this code. So we're going to specify what our function does. But there will be cases when we call Apple functions, and all we're going to have to do is call the functionality, pass in the required parameters, and then Apple will already have written this internal logic, so we don't need to do that. Functions can also have multiple parameters. We don't have to only add one parameter. So let's see how the syntax for multiple parameters differs from a single parameter. Let's go ahead and remove our function call. We're no longer going to call this function, although we could, if we need to in the future here. And we're going to once again create a function. We're going to use that func keyword. And we're going to say turn off appliance. And we're going to pass in two parameters here. So the first one will be the appliance name. And we'll specify that this is going to be a string. And we're going to do comma is on. And we're going to specify this is going to be a bool. And then we'll add our curly braces here. And we're going to use some control flow. We're going to say if is on, which is the same thing as saying if is on is equal to true, right? This is the equivalent of writing if is on. We're going to be able to add a print statement here. So I'm going to say print line. And we'll say please turn off the, and we'll use some string interpolation here, and we'll access our appliance name. And we'll add an else statement below this. We can say else, and we'll say print line, and we'll add some quotes, and we'll do I actually turned the, and we'll pass in our appliance name. And we'll just add a little bit of text here at the end. We'll say off already. So what this function is going to do here when we call it, we're going to pass in two parameters. We're going to pass in a string that's going to be our appliance name, and we're going to pass in a bool, which is going to be either true or false. So we're going to use a little bit of control flow here. We're going to say if is on, which remember is the same thing as saying if is on is equal to true. These are the equivalent of one another. We're going to be able to print this statement out. So if we pass in true, we're going to print out please turn off the, and whatever we pass in as the appliance name, we'll print here. Else, right, if we pass in false, we can say print line, I actually turned the, and we'll pass in the appliance name off already. So let's go ahead and just remove this. It's good to get used to different styles of syntax here. So just remember that that's an equivalent of testing if it's true. And we can call this function by saying turn off appliance. And let's do the stove first. And first we'll pass in true. So we'll see please turn off the stove prints out. Notice that we get access to is on, and we can do some control flow on it. And we also get access to the appliance name, and in this case all we're doing is just doing some string interpolation. Now we can switch this up. Let's put in false this time, and we'll see that our else statement now evaluates because the value we're passing in for this parameter has changed from true to false. And if we change the appliance name to television, we're going to see that this now updates, right? So I actually turned the television off already. Prints out to our console here. And this would work with something like toaster, and we could pass in true, and we'd see please turn off the toaster now print out. So we see that based upon the parameters we pass in, we can have very different bits of functionality run, in this case just using a little bit of control flow. So now we're going to learn about functions that can return a value. So as usual, we're going to go ahead and remove our previous function call. And we're going to create a new function. And we're going to call this function addition function. And we're going to basically replicate the functionality for the plus operator. In fact, we're going to mimic it, and it's going to be a little bit redundant, but it will show you how return values work from a function. That's really the point of this lecture. So we're going to say func addition function, and we're going to pass in two arguments. First argument, and we're going to specify that this is going to be an integer, we need colon int. And then we're going to do common second argument, and we're also going to use an integer. Now this is the new part. We're going to do dash angle bracket, and we're going to specify that this is going to return an int. Let me just move this a little bit to the right so we can see this all in a single line here. Now immediately we get an error here, and it says missing return in function expected to return int. So it's telling us that we are now telling this function that it will return an integer. So for now we can just return 0, and that will make that go away. We're returning an integer. We're just going to return 0 for now. We're going to update this in just a second here. So what are we going to do here? Well, we're going to take the two arguments we're going to pass in when we call this function. We're going to add them together, and then we're going to return that value. So we're going to say let sum of arguments equal first argument plus second argument. And then we'll return the sum of arguments. So what's going on here in this function? Well, we're using that func keyword again to define a function. And the name of this function is addition function, and it takes two parameters. The first parameter is named first argument, and the second parameter is named second argument. Notice that we separate these with a comma. And then we have this new syntax here, the dash angle bracket, and then we specify a type. And specifically, we're going to be returning an integer here. So inside of the body of our function here, we first create a constant named sum of arguments, and we just add our first argument and our second argument together. These are both integers, so we can add them using the plus operator. And then we're going to return a value here, and we know sum of arguments is an integer because we're adding two integers together. So we are now, in fact, returning an integer, right? We're returning some value. We don't know what this is going to be yet because we haven't called this yet. Once again, first argument and second argument are going to be dynamic, but we know there will be integers, so we'll be able to return an integer here. So let's go ahead and say var addition answer of integers equals addition function, and let's pass in 2, 4, and we'll see 6 prints out now. So how is this working? Well, we are calling the function. We're going to look at the right side of this equals sign first, or the assignment operator we can say here. And we're going to say, we're going to call this function addition function, and we're going to pass in 2 and 4. So the value of first argument is 2, and the value of second argument is 4. And first argument, which is 2, plus second argument, which is 4, is equal to 6. So we assign that to the constant sum of arguments. And then we return sum of arguments, which is equal to 6. So we're going to return 6 here. And then we set addition, oh, this is missing a W, addition answer of integer equal to 6. So now addition answer of integer is equal to 6 because we've returned that from this function. If that still doesn't make sense, let's actually do something with addition answer of integer. So we're going to say let final answer equal addition function, and we're going to say addition answer of integer, and we'll pass in our second argument. We'll just pass in 5 here, and we should see final answer is 11, and we can even just add a print line statement here, and we'll just pass in final answer. So what are we doing here? Well, addition answer of integer is 6. We figured that out already. So we're going to recall this function again, right? The whole point of creating functions is we can call them over and over and over again, and we save ourselves from having to write all this code over again. So we pass in 6, and we're going to pass in 5. So we go in here, first argument is equal to 6, second argument is equal to 5. So we add 6 plus 5 together, we get 11. So sum of arguments is equal to 11. We return 11. And that gets set equal to final answer, right? So when we return a value, if we don't capture it either in a variable like here or a constant like here, it will just disappear, right? If we go ahead and just remove these 2 lines of code here, I'm going to add them back so you don't actually have to delete this. Yeah, this will evaluate to 11, but if we don't capture it, it just disappears, right? 11 gets evaluated. We don't do anything with it. We might as well have not done this, right? Well, by adding the constant final answer, we're able to capture that value in the constant, and we can do something meaningful with it. Specifically, in this case, the real meaningful thing we're going to do is just print it out, right? We would just print this out to our console if we were doing this in a regular Xcode project. But, we could do additional math. Maybe we update our view based on this, or maybe we pass this in somewhere else, or, there's a lot of things we could do with this information that's being returned. We're just really trying to understand right now that we can return a value and what that means, because it can be such a hard idea to wrap your mind around if you're new to computer programming. A function can return a value. When do I need to do that, and what is the use case? Well, here we're returning a value and we're understanding that if we don't capture it, it just disappears, right? It still evaluates to 11, but nothing meaningful can be done with it. So that's why we're going to grab it and set it equal to this constant named final answer. So the first thing we're going to do here is we're going to go ahead and just add some returns here. And having a return type, I think, is so hard to comprehend when you're starting out that we're going to actually practice this again with a string. And I'm actually just going to leave this bit of code. Usually delete all of this stuff. We can remove the print line, but let's just leave these 2 lines of code here to make this a little bit easier to understand moving forward. Now, this time let's create a function. And we're going to say func, and we're going to say hello world string. And this time now, let's not pass in any parameters. Let's just return a string. And let's add our curly braces. So even before we get started figuring out what this function should do, let's just take a look at the syntax we've used. We've used this func keyword. We have a name. We have our empty parentheses, which means that we're not passing in any parameters. And this time we're going to return a string. Last time we returned an integer. So we immediately get an error. And that's because we're not returning a string. So we can make this go away by just saying a return, and we'll return an empty string. We're going to update this in just a minute. So the whole point of this function is just simply to return a string, and this string is going to say hello world. And this function now returns hello world, the string, and we can call this function by saying var hello world is equal to hello world string. And what this is going to do is it's going to set the variable named hello world equal to a string hello world, and we're going to be able to manipulate this. So we can change the string. We can say hello world is equal to hello world plus, and we could add an exclamation point at the end. And if we printed this out, we'd be able to print out hello world, and we'd see hello world with the exclamation point here. So we can see that functions can return something, and we don't need to do crazy logic. As long as it returns the specified type, the function is doing what it's saying it's going to do, right? Specifically, all it's saying it's going to do, or it's guaranteeing, is it will return a string. And once again, we could capture that by calling this function and setting it equal to the variable hello world. And now that this variable named hello world is equal to a string here, hello world, we can manipulate it by saying hello world plus, and we can add an exclamation point to the end, right? Because we can add a string to another string and update our current string. And then we can just print that out to our console. There's one other thing I want to show you in this lecture, and that's we can call a function inside of a function. Specifically, we can call the function we added before, print hello world, down here. So we can say print hello world. And when we call this function, we're going to see hello world, hello class printout. So let's go ahead and take a look at our console here. And we're going to see hello world, the exclamation point, and then hello class, and then hello world here with the exclamation point. Now we can change this a little bit to make this a little bit easier for us. We can add a second exclamation point, for example. And let's go back here. We see that the hello world with 2 exclamation points is printing out last. So what's happening here is, let me go ahead and exit out of here. We know that when we call the function print hello world with 1 exclamation point, and hello class will print out. So when we go down here and we call this function, specifically we're going to call it here, hello world string, what happens is it goes through these lines of code here. It starts at the top and it works its way down inside of these curly braces. And the first thing it gets to is, okay, well, I need to call a function hello world. So it goes up here and it runs this bit of code here. And when it's done running this code, it continues on. And the only other thing it needs to do is return hello world. So it returns hello world, and then that comes down here, and we set that equal to the variable hello world. And then we add 2 exclamation points, and finally we print this out to the console. So that's why we see this come out last, right? We see hello world with 2 exclamation points come out last, and that's why we don't see it before. So the order really matters here, right? This print hello world is occurring before this print line hello world is called. So let's go ahead and open up our Lions and Tigers project. And this video, we won't be writing any code, so we get a little bit of a respite here. We're going to open up our viewcontroller.sw file, and you can just kind of follow along. You don't actually need to code anything here. In this video, we just want to take a look at some of the functions that we've already implemented or added, just so we can finally see, okay, this is what I just learned in our last series of lectures, and this is where it's already being applied inside of my project. So the first one we see here is this override keyword, which we're going to ignore for now. But the rest of this syntax should look very familiar. We have this func keyword, we have a name, we have some parentheses here, and then we have curly braces. Right? So in this case, Apple is actually calling viewDidLoad for us, but you know that we could hypothetically call this if we went to another function. All we'd have to type in is viewDidLoad, and we would be able to call this function, right? So it works the same way we've seen, except that we have an override keyword, which we don't yet know, and that this is being called by Apple instead of us explicitly calling this. But it's a function that takes no parameters, its name is viewDidLoad, and it has curly braces, right? So this is somewhat familiar to what we've seen before. We have another function here, and once again this has the override keyword, which we can ignore for now. But once again it has the func keyword, which we're familiar with, did receive memory warning, some parentheses, and these curly braces, right? And inside of these curly braces, again, we can do some bit of logic here. Once again, this function is going to be called by Apple automatically. We're not going to have to worry about this. But this parameter doesn't return anything, and it has no parameters. Well, we have our final function here, and we have this @IBAction keyword. This is just a hint to the compiler that this function is going to be called from a button in our storyboard that we set up. And we have this func keyword, and we have a name, next bar button item pressed. And we have a parameter in this case, and the name of the parameter is sender, and its type is UI bar button item. So we know that we could access sender inside of this function, and we could do additional things to this. We could do like set, and we could set all of these different items for our bar button item. Now we're not going to actually do anything with this parameter for now, but you should at least now see the connection between all of those videos or lectures that we just went through, and finally understanding some of the syntax we've been seeing in our projects. Now we're going to write a function inside of our Lions and Tigers project. So let's go ahead and reopen that. And we're going to go and write this function in the tiger.sw file. So far we've seen all of our functions in the view controller file, but we're going to see structs can also have functions, and this is going to allow our Tiger instances to do things. So what do I mean by that? Well, let's write a function here. So we're going to use that func keyword we're so familiar with, and then we're going to write chuff. And just in case you're curious, what this means is our Tiger is going to be able to make a noise, kind of like purring, but chuffing is very particular to tigers. They don't roar like lions do, they chuff. So feel free to check out the YouTube link to see what I mean. It definitely is a different sound. And all we're going to do here is we're going to write a print line statement, and inside of here we'll say tiger, and we'll do chuff, chuff. And now we have a function written here. When we call this function, all that will happen will be that the string here, tiger, chuff, chuff, will print out to our console. So how can we actually call this function? Well, this is what we call an instance function. And what this means is we actually have to call this on an instance of our tiger. If we had another function inside of the tiger struct, we could also call this function chuff in that other function as well. But since we don't have another function, we're going to call this on an instance of our tiger struct here. So where do we have an instance of our tiger struct created? Well, let's go over to our viewcontroller.sw file, and let's locate the viewDidLoad function. And we're going to see that we have a few instances of tiger here. So right below here, we can write my tiger dot chuff, and we can go ahead and run our application here. And then we should see the print statement that we wrote inside of the chuff function print out to our console. So while we're waiting, oh, there it goes. Chuff chuff is now printing out, so that worked properly. So notice the notation here. We take our instance and we use our dot notation, and we can call the function chuff that we define in our tiger struct. Notice the use of the parentheses here, which means we're not passing any parameters, but it is a function call because we do see these parentheses here. So we can also call the chuff function on any of our other tiger instances. So we can go down here and say something like second tiger.chuff, and we can rerun this application. Now that we're calling this twice, we should see this print line statement twice. So we see tiger, chuff chuff, and then notice we have another print line statement that occurs before second chuff chuff because we have our print line statement here. Then the code goes down, and then it calls chuff on our second tiger instance. So we can call our chuff function on any of our tiger instances. We could call it on third tiger and fourth tiger as well. Now we want to write another function, and we're going to write this function again in the tiger.swift file, and we're going to practice two things in this video. We're going to start practicing the self keyword, and I mentioned earlier that we'd be discussing this, so this is kind of where we're going to start seeing it. And we're also going to be practicing adding a parameter to a function, and we're actually going to start with that. So let's go ahead and declare a new function here. We're going to say func, and we're going to say chuff a number of times, and we'll pass in an integer parameter. So our argument will be number of times colon int, and this function won't return anything. But what it will do is it'll call this function chuff a certain number of times based upon the number we pass in. So we're going to use a for loop here. We're going to say for var chuff equals 0, and we're going to say chuff is less than number of times, and we'll do colon plus plus chuff, and we'll add some curly braces here. And let's try calling this function chuff. Well, in the past, all we've had to do is write chuff like this, but we're actually going to get an error. So let's take a look at our error here. It says invalid use of, and it shows us some parentheses, to call a function of non-function type int. And basically what's happening here is there is a name conflict because we have our variable name chuff here. It's getting confused. And what it wants us to do here is it wants us to use the self keyword to access this function. Now, structs and classes both can access functions by using the self keyword. If there's no name conflict, if for example we wrote this up here, chuff, we would see there would be no conflict. But if there is a conflict and you need to be very specific that you want to access the function chuff, then we can use the self keyword. So let's take a look at our view controller example. We saw in a class, and this does not apply to structs, this only applies to classes, that when we used the self keyword, we were able to access our properties. So we had some properties defined here, my image view, name label, age label, and breed label, and we were able to access them using the self keyword. And once again, we were required to be very specific here inside of our closure that we wanted to access these properties, and in order to do so, we needed to use the self keyword. So let's do a little bit of refactoring here, and let's determine when we could use the self keyword, when it would be okay, and when it would not be okay. So how about for my tiger? Could I say self.mytiger.name? And the answer is no, because my tiger is a local variable. It's defined inside of the viewDidLoad function here. Right? We're not declaring this as a property, so it's invalid to use self. We can only use self to access our properties here. So where else do we have some properties? Well, we have my tigers, so we can actually access using self, and we can say self.mytigers, and that's completely valid. We can also update our image views and labels here by using the self keyword. So we can say self.myimageview.image. We can say self.nameLabel, self.ageLabel, and self.breedLabel. But how about for second tiger? Was this declared as a property? No, it was not. So if we try to write self.secondTiger.name, this is invalid. So once again, we are going to check if it's a property. So if it's my tigers or any one of our IB outlets or the current index, then we can use the self keyword. So let's keep doing our refactor. How about third tiger? Do we think we can use self for this? And the answer is, once again, no, this is not a property, and the same idea applies to our fourth tiger. We can use the self keyword for my tigers because my tigers was defined as a property. And we can see that this also will apply to all of the code we wrote in the next bar button item pressed function. So we see random index. Is random index a property? Let's try it. Self.randomindex. No, we define random index inside of this function. So its scope is local. It's not accessible in multiple functions, and we can't access it with the self keyword. But we can access current index with the self keyword because current index is a property. So we can update both of these current indexes to use the self keyword. We can also update the self.mytigers and indexing into it using random index with the self keyword because once again, mytigers is a property. So this is how we can use self to access our properties inside of a class. All right, and how do we know this is a class? Well, if we take a look at the top here, it has the class keyword. Now, if we use a struct, we cannot access properties using the self keyword. We can only access functions. So if I try to access age here, if I try to say self.age is equal to 2, I am going to get an error, and it's going to say cannot assign to age in self. So this is the first example of a difference we've seen between a class and a struct. In a class, we can access a property using the self keyword. In a struct, we cannot. Now, what are the similarities between a struct and a class? In both a struct and a class, we can access a function defined inside of that class or struct using the self keyword. So here we're able to access the function chuff using the self keyword. And if we go over to our view controller, if we add an additional just test function here, let's add a function here, we'll say func, and we'll say this is going to be called print hello world. And this function won't return anything. And all this function should do should be to print out hello world. We can access this function, print hello world, in any of the functions inside of our view controller class here using the self keyword. So we can access it at the bottom here. We can say self.print hello world and call this function using the self keyword. Now, we're not required to use the self keyword. We can remove that, but it is possible to use the self keyword. And we just saw a use case in our tiger struct when we had a name conflict where it was really useful to use that self keyword. So both structs and classes, when accessing functions, can use the self keyword. Now let's try running this. Let's make sure this works. We should see print hello world occur at the bottom. And we see hello world is working because we're able to call this function at the end of our viewDidLoad function. So what exactly is self? Well, self is the implicit instance of the class or struct you're currently working in. So when we're in the view controller class, when we say self, we're referring to the current instance of view controller that's being used. In this case, there's only one instance. Right? So self is the view controller that we're currently displaying on the screen, and the view controller manages the view, which is what is displaying the image view, right? We added an image view on top of the view. So when we're saying self, when referring to the view controller, we're referring to this entire view controller, right? That's managing this view. Now, when we're referring to tiger and we say self, this is relative based upon the instance of the tiger that we're looking at. We have 4 instances of tiger, so there's 4 implicit instances of self, depending on which instance of tiger we're working with. So let's just actually quickly go ahead and remove this print hello world. This is just gonna confuse us. We can just delete these 2 lines of code. Hopefully that you're able to delete the function, and then where you're calling the function here, just clean up your code a little bit. Let's talk about self and how there's 4 different instances of self running around for our tiger, and hopefully that will help clarify the idea of self, and at least you can start thinking about it. Well, we added a new function, and we wanted to have our tiger struct call the chuff a number of times, and specifically we need to call this function chuff a number of times on an instance of our tiger struct. Now let's just do this at the bottom of our viewDidLoad function here. So we can say my tiger dot chuff a number of times, and we'll pass in 3. So let's go ahead and run our application here. And notice that we didn't use the self keyword, right? Because my tiger is not a property. And we see chuff, chuff, chuff prints out here, right? We added 3 times and we're calling this above for our second tiger, right? So we did second tiger.chuff, and now we do my tiger.chuff a number of times, and we added 3, so we got 3 more print statements inside of our console here. Now, when we say my tiger.chuff a number of times, and we take a look at our tiger struct here, the instance of self is the instance of our tiger struct we created that we named my tiger. However, when we go back to our view controller, and let's call this on our second tiger, so we can say second tiger.chuff a number of times, and let's call this twice this time, so we should see 2 more appear. Let's go run our project. The second time we call this chuff a number of times, self will refer to the second tiger instance that we created, right? So we created 4 instances. There's 4 different instances of self, and depending on what functionality we're using here, right, it's going to refer to any one of the number of 4 instances we created of our tiger struct. So it's relative, right? Self is relative based upon the instance we're using. So when we create a bunch of instances of our tiger struct, it could be any number of those instances depending on which one we're using, right? And then self will become one of these. Or if we're in our view controller, right, there's only ever going to be one instance of this specific view controller in this application. In other applications, you might reuse your view controller, so you might have more than one, instance of self. But in our case, this view controller is only going to get created once. We're not going to re-add a new view controller on top of the same view controller class here. So when we're referring to self, we're always referring to the one that's showing up on the screen here. So hopefully this is helping you to understand the idea of self. Self gives us access to our properties and our functions, and it helps us prevent name conflicts. And we've also seen that we are required to use this when we're updating our properties inside of a closure. So self can be really handy, and we're going to really try to use self in the future. You're actually going to see in the coming projects me using both types of syntax, where sometimes I'm going to just simply do current index, right? That is equal to random index. And you should also remember that this is the same thing as saying self.current index, right? These two are equivalent, but sometimes I am required to use the self keyword. And later on, you're going to see that I'm going to start using the self keyword to refer to my properties quite a bit. I actually really like to do it that way. It's just kind of a personal habit. But you're going to figure out what works best for you, which way you like to view it best. But there are going to be times when you have to use the self keyword, like our example when we had a name conflict here and we had to access the function using the self keyword. So as a quick wrap up, just one more time, because it can be so confusing here. For structs, we can access functions that we define inside of the struct using the self keyword. So in the function chuff, we could call the function chuff a number of times using the self keyword. We wouldn't want to do this because this would create kind of an infinite loop, but that is possible. But we can't access our properties using the self keyword inside of a struct. Now in our class, right, classes can do pretty much everything a struct can do. So our class is capable of accessing functions using the self keyword, and we proved that when we added the hello world function. And classes are also capable of accessing properties using the self keyword. And later on, we're going to make our own class from scratch so you can really understand what's going on here. And we'll practice using the self keyword to access a property as well. In this video, we're just going to spend a few more minutes talking about the self keyword because it's so common to use this in computer programming, be it iOS or any other computer programming language you pick up. And quite frankly, when I was starting out, self took me forever to figure out. So hopefully you'll understand it a little bit better at the end of this lecture. If not, please feel free to post. Maybe you can ask some questions and help clarify things. really the best way to understand self is to just keep coding and to see it used in action. So we're going to make an effort to use this in our upcoming code and our upcoming projects. You're going to see this used. So by the end of this course, you should be a master with self. So if it doesn't make perfect sense, stick in there and it will eventually make sense. So self is relative, and that's really the first topic we want to talk about in this lecture. When we're in the view controller file, we can use self to refer to the view controller file. When we're in the tiger.swift file, we can use self to refer to the tiger struct. And when we're accessing functions, if we are in either one of these files, or if we're in the view controller class file for accessing a property, when we're using the self keyword, we can only access the functions and properties defined in this specific class or struct. So it's not valid to try to say self.shuff. We're going to see if we try to do that, we're going to get an error here. And the reason is chuff is not defined inside of the view controller class. It's defined over in the tiger struct. So we were able to say self.chuff, and let's add our parentheses here. If we try to run our computer program here, it's going to say view controller does not have member named chuff, meaning that there is no function named chuff here. And the same would be in the tiger struct. We couldn't say self.viewDidLoad, right? This is not accurate because we don't have access to the viewDidLoad function. Once again, if we run this, it's going to say now the tiger does not have a member named viewDidLoad. So it's important to remember that self is relative, and we can access our functions and properties when we're in a class, or just our functions when we're in our struct. Now the other thing I want to show you here is if we create a local variable, let's say we create one named current index, and we say here var current index is equal to, and let's set this equal to a string. If we try to update our current string here, we're going to say current index is equal to, and we try to set this equal to 2, we're going to get an error here, and it's going to say string does not conform to protocol integer literal convertible, which is basically saying I'm trying to access this local variable you created, and you said it was a string, and now you're trying to set it equal to some number. So in this case, when we have a naming conflict, like we saw in our previous lecture, we would just use the self keyword to specify that we want to access the property, we don't want to access this local variable. So keep that in mind when you have a naming conflict. You can either change the name, or much easier, you can simply just use the self keyword to specify that you want to access a property. So now we're going to add an additional function to our tiger struct, and this time we're going to practice having multiple parameters, and we're also going to practice adding a little bit of control flow into our function so we can start seeing the flexibility of a function as well. So the first thing we need to do is we need to create an additional function. So we're going to say func, and then we're going to say chuff number of times, but this time we'll add 2 parameters. We'll say number of times, we'll specify this is an int, and then we'll add a bool. We'll say is loud, and we'll make this a bool. Now it's important to note here that even though we have the same name here, because we have a different number of parameters and these parameters are different, these are 2 different functions, so there's no naming conflict here. Because we've added is loud as a bool here, these are now very distinct functions. So we can do a little bit of control flow in here. The first thing we're going to do is we're going to write a for loop, and we're going to say for var, and we'll say chuff times equals 1, and then we'll say chuff times must be less than number, or less than or equal to number of times, and then we'll do chuff times plus plus. And then we can add our curly braces. So what's going on here? Well, I'm writing this for loop a little bit differently, just so you can see some contrast from our previous for loop. This time we're going to call this chuff times instead of chuff. And then we're also going to set its initial value equal to 1. So when we do our test here, we're going to say chuff times must be less than or equal to number of times, because we're starting this at 1 instead of 0. And then we can also add some control flow inside of this for loop. We're going to say if is loud we'll say chuff. And then we can say else, and we'll do print line, and we'll do tiger purr. So what's going on in this function? Well, we use the func keyword to define a function named chuff a number of times, and we added two parameters. Number of times is an integer, and isLoud is a bool. So when we call this function on an instance of our tiger struct, we're going to have to pass in both a number and a bool, either true or false. Then we run a for loop here based on the number of times we pass in here as a parameter. But this time for our for loop, we set chuff times as the variable equal to 1 instead of the past when we've set our variable equal to 0, like in our previous example. And because of that, we say chuff times must be less than or equal to number of times instead of chuff is less than number of times. And then we increment by 1, and notice this time I'm doing the plus plus on the right side instead of the left side like we did in our previous example. Then we use an if and an else statement here. We test if the bool is loud, and if this is true, remember that if is loud is the same thing as saying if is loud equals true. These are the equivalent. So we can call the function chuff. Otherwise, we'll have an else statement here where we'll just print out purr. So let's go to our view controller, and we'll just call this function on my tiger. So we can say my tiger.chuff a number of times, and we'll choose our second option here. And notice that we're getting this autocomplete. It's recognizing we created this function. And this time we're going to pass in 5, and for isLoud, we'll just pass in false. And now we can go ahead and run our application here. And we should see purr print out 5 times. So we see purr now prints out 5 times. Now if we switch isLoud to true, we'll see chuff print out 5 times. And obviously we could also change the number here to make this print out a different number of times. So the real thing you want to take away from this lecture is the ability to create an additional function, and that if we add a different parameter, it becomes an entirely new function here. However, if we try to name this exactly the same thing, this would cause a conflict, right? Because this is exactly the same function we defined before. The other thing we want to take away from this is we can have multiple parameters, and we can pass this in, and we can do different things with some control flow. We've got 2 more functions that we want to add to our tiger struct. So we're going to get started with the first one, and we're going to add this to our tiger.swift file. So let's once again use the func keyword, and we're going to say age in tiger years from age, and we'll pass in a parameter here. It'll be called regular age, and we'll make this an integer, and this is going to return an integer. So we'll add our curly braces here. Now this is a little bit different than the functions we've worked with so far. This is the first function we're creating in our tiger struct that's going to return a value. So the first thing we're going to do is we're going to create a constant, and we'll say let new age equal regular age times 3, and then we'll simply return new age. Now if you want to make this all a single line, you could simply do return regular age times 3. I'm breaking this out right now. This would be the same thing. I'm breaking this out right now to make this a little bit easier for us to see each of the steps. And I think when you're starting out, it's sometimes easier to write each step out and only concentrate on, okay, what piece of information am I trying to get next? What am I trying to do with this information? Rather than just trying to drop everything together. If you have a little bit more experience, feel free to condense your code. So we have a function here, and it's named age in tiger years from age. And we are passing in one parameter here, and it's an integer, and the name is regular age, and it returns an integer. And first what we do is we create a constant named new age, and we grab our parameter regular age and we multiply it by 3, and then we return that value. So whatever parameter we pass in here, we're going to multiply that by 3 and return it. So let's go over to our viewcontroller.swift file, and let's update the age of our tiger, and we can update our tiger's age here by saying my tiger.age is equal to mytiger.age in tiger years from age, and we'll pass in mytiger.age. Now, you might say this is a bit silly. Why wouldn't we just call this function here when we're setting up our age initially? And the point is to really see this return value. I want you to practice using this function, passing in a value, and it's not so obvious here we're passing in a property of our Tiger instance here. So just getting used to this syntax is really important to do. It'll just make it a lot easier when you see us starting to pass in parameters that aren't really obvious later on, that this is just a property, this property is an integer, so it's okay to pass this in as a parameter for this function age in tiger years from age. And we also see that we're calling this function on our mytiger instance, and then we're going to update the property of mytiger.age as well. So we're going to practice this again with our second tiger, and we can say second tiger.age is equal to second tiger.age in tiger years from age, and once again we'll pass in the second tiger's age. And once again what we're doing here is the second tiger has a property age. This is an integer, and we know that the function age in tiger years from age returns an integer, so we can call this function on our second tiger instance, and we're going to pass in the current age of our second tiger. This will return a value. Specifically, it'll multiply the current age by 3, and then we'll update the value of the age property for our second tiger. So let's also do this with our third tiger. And we'll say third tiger.age in tiger years from age, and we can update this to be third tiger.age. And we can also do this with our fourth tiger. Age in tiger years from age, and we'll do fourth tiger.age. So hopefully this isn't too confusing. I know the syntax is a little bit more advanced than things we've seen in the past, but getting used to the idea of accessing properties, updating properties, and specifically having a return value from a function like we have in our tiger.swift file here is really important. As we start playing with this more and more, we're going to see different types of return values from different functions. So getting used to this syntax will be super useful as we continue to write our computer programs together. We have one more function we want to add to our tiger struct, and this function is going to be a little bit more advanced than the functions we've worked with in the past, so just stick with me. We're once again going to practice a return value from a function, because this can be one of the more difficult things to grasp for a function. So let's go ahead and just use the func keyword, and we're going to say that this function is going to be called random fact, and this function is going to return a string. And the first thing we're going to do is we're going to create a random number. So we're going to say let random number equal int, and we're going to do arc for random underscore uniform, and we're going to do uint32, and we'll pass in 3 as the parameter. Now just be very careful with the syntax. It's really easy to get these parentheses wrong. Just make sure you're looking at this, or make sure you look at the notes, because the notes will also have the proper code. So just make sure you get this in there correctly. Right now we have an error here, so we can just return an empty string, and you shouldn't see any errors when you take a look at your code right now. So if you see some errors, there's something else going wrong, just make sure you're getting the syntax in there correctly. So the first thing we're going to do is we're going to create a variable, and this variable is going to be called random fact, and we're going to specify that it's a string. And the reason we're going to specify this is we're not going to immediately assign it a value. So we'll run a test based on this random number, and the reason we chose 3 as the number of possible random numbers we want, right, 0, 1, or 2, is that we're going to have 3 different potential random facts. And we're just going to kind of hard code that for now. And we'll first test if the random number is equal to 0. And if it is, we'll set up the random fact variable to be equal to the tiger is the biggest species in the cat family. And then we'll add an else if. We'll say else if random number equals 1. And we can say random fact. And we'll set this equal to tigers can reach a length of 3.3 meters. And finally, we'll add an else statement at the bottom here. And we'll say random fact equals, and we'll say a group of tigers is known as an ambush or streak. And incidentally, we can use our apostrophes here as a way of specifying that, we want to highlight these words inside of our string here. We can't use quotes because that would conflict with our string, so it's really nice to use apostrophes. And finally, when we want to update our return here, we want to actually return our random fact. So let's talk about our code before we actually implement this. The first thing we're going to do here is we're going to say we have a function and its name is random fact. It has no parameters, and incidentally, you can add a space here, or you can just adjoin your parentheses to the name of your function. That's fine as well. And then we're going to return a string here. So we have our curly braces. We know that we need to return some string. So we're first generating a random number, and we pass in 3 as our parameter here. So we're going to return 0, 1, or 2. And then we create a variable named random fact, and we specify that it's a string, but we don't yet assign it a value. So we use an if statement. We say if random number is equal to 0, right, equals 0, we're going to specify that the random fact should be the tiger is the biggest species in the cat family, right? If our random number is generated as 0. If our random number comes back as 1, we'll assign random fact the value tigers can reach a length of 3.3 meters. And if our random number is equal to 2, then our random fact will be equal to a group of tigers is known as an ambush or streak. And then finally, whichever value we give it, we'll return the random fact. So this random fact generator will give us back, some bit of random information. Specifically, it'll give us back a random string that we'll be able to use to update our UI. So right now, we don't have a random fact label in our storyboard. So let's go ahead and head over to our storyboard here. And let's update this. Let's go ahead and drag up our 3 labels. Make sure they stay on the storyboard here, but we're going to move them up. And then let's add an additional label here. We can just add this right below. And let's enlarge this. Let's make this a bit bigger. And let's also make this white to make this consistent with all the other labels we've added. And let's also set the lines to 0, right? Because our random fact might be quite large. We might need more than one line for our label here. And let's hook this up. So let's hold down the Alt key and press on viewcontroller.swift. And let's close out our panels quickly just to give ourselves a bit of space to work with. And we're going to scroll to the top of our viewcontroller.swift file. And let's generate an IB outlet. So we're going to hold down the Control key and drag into our viewcontroller.swift file. And we're going to call this random fact label. And we're going to go ahead and connect this up. So we now have a label where we can display the information from our random fact function that we added to our tiger struct. So let's go back to single view, press our single view, and let's open up our panels again. And let's go to the viewcontroller.swift file. So we're going to update the random fact label in 2 spots. The first place we want to update this is when the view initially loads up. So let's go ahead and add this to our viewDidLoad function. And we're going to do this right below updating the breed label. And again, this is in viewDidLoad. So we're going to say self.randomFactLabel.text is equal to myTiger.randomFact. And we know that the random fact function will return a string. And we know that the random fact label's text attribute or property is a string. So we can update this with a bit of random information from our function random fact. We also want to update this when we press our next bar button item. And when we press this, we're going to want to update the random facts. So hopefully we'll see a bit of new information. Now, again, there's a chance we could see the same one, but if we press this enough, we should be able to get through all of our random facts. So we're going to say self.randomFactLabel.text is going to be equal to tiger.randomFact. And notice that again, we're calling this function on an instance of our tiger struct. And we're going to be able to once again update the text attribute, which is a string, with the string that's returned from the random fact function. So let's go ahead and run our application here and see if we can see some random facts. So we see a group of tigers is known as an ambush. We can press next. And tigers can reach a length of 3.3 meters. So our random fact is working properly. In this lecture, we'll learn about switch statements. So we're going to go ahead and create a new playground. So we're going to select Xcode, get started with a playground, and we'll call this switch statements. And we'll make this for the platform iOS. We can press next and then press create. And let's expand our project and remove the first line of code. So the first thing we're going to want to do when we create our switch statement is we're going to create a variable here. We'll say var x is equal to 4. And based on the variable here, we'll actually have our switch statement work. We'll see how that works in just a second. Switch statements are basically an alternative to if and else if, and they kind of have a very specific use case, and that's usually when we're going to increment some variable by 1. So let's type in switch, and we're going to specify the variable we want to test here. So we're going to test x, and we'll write case 1, colon, and we'll type in print line, and we'll say the value of x is 1. And then all switch statements need a default case in case one of these cases is not true. So we'll type in default below this, and we'll type in default colon, and we'll type print line default value printed. So we'll see right now, because x is equal to 4, default value printed is printed out because our case here only tests for 1. So if we switch this over to 1 here, x is equal to 1, so the value of x is 1, it gets printed out here. So let's add a few additional cases here. We can say case 2 colon print line. We'll say the value of x is 2. And we'll do case 3 print line. The value of x is 3. And we can do case 4 print line. The value of x is 4. And case 5 print line. The value of x is 5. So if we switch the value of x up here, we're going to see different cases evaluate. And it's basically testing, is this number equal to the variable we're testing here? So if we had var y is equal to 10, right, and we switch this over to y, we'd see that we were no longer testing x, and because y is equal to 10, our default is going to print here. But we'll just do x for now. We can go ahead and remove this. We'll say switch x. And by changing the value of x, you can get all of your different cases to print out. So switch statements, as I said, are very useful when we have a variable that's going to increment by 1 here. Often when we generate a random number, right, that often increments by 1. So it's really nice to use a switch statement there. But they're not as useful as if statements, in my opinion, because if statements are a little bit more flexible. But when we have a whole bunch of different cases, it's kind of nice to organize them this way. Now, for those of you who are coming from Objective-C, you'll remember that when we had cases and switch statements, we had to actually break out after the case was complete. Otherwise, all the other cases would evaluate. And that's not the case here. As soon as one of these evaluates the true, in this case, the value of x is equal to 4, the switch statement terminates, and we would go down here and do whatever code we had written down here. So it's a little bit different than Objective-C if you're familiar with Objective-C switch statements. And we'll see a few use cases of this in the future. In fact, you can try this in the next challenge you're going to have, which is going to be the 99 red balloons challenge. And you're going to be able to attempt to use a switch statement if you'd like, or you can use an if and else statement as well. So welcome to your 99 red balloons struct challenge. This is going to be a particularly difficult challenge because for a lot of you, you just started playing with structs and properties and functions. There's a lot of new concepts floating around. So if you get stuck, definitely check out the solution videos. You're going to notice that there's 4 of them because this challenge is a little bit more involved. But if you're feeling pretty comfortable with the concepts we're showing you, definitely try this on your own. Go for it. If you do watch the solutions, I highly recommend that you go back and you try to solve it again without it. And maybe you make some adjustments to the code to really make sure you're understanding the concepts that we're showing you. This is pretty important and very foundational for understanding how to code in Swift. So the goal of this project is to add a UI image view as your background here. You're going to add a label. We can see that we're setting up a default image here for our background. This you can grab from the 99 red balloons assets that you can download. And each time you press the next button here, I want you to show off a different image. It doesn't matter if you show the same one twice, but you should randomize the image that you're assigning to each balloon instance. Now what I mean by that is you're going to create a struct called balloon, and it's going to have both a number and an image. And each one of the balloon instances that you create, you should create 99 of them and store them in an array, should have a different number and should be randomly assigned a balloon image. You can use a switch statement. You could also use if and else if to randomly assign an image using the arc_rand_uniform. And using the random number return, you're going to be able to randomly assign an image. So I don't care if it keeps coming back with the same random number. That's fine. If you want to solve that problem, that's up to you. But I do care that you are randomizing the image that you're going to be adding to the balloon instance. So definitely try creating your own struct here. Try adding a for loop, iterating over it, creating a bunch of balloon instances, adding that to an array, and then using that to update the UI each time you press the next button. Let's get started solving the 99 red balloons challenge. So the first thing we're going to do is open up Xcode, and we can create a new Xcode project. And we're going to choose iOS application, single view application, and select next. And we can call this 99 red balloons. And I'm going to leave all my other options the same here. We're going to make sure we have the language Swift selected and universal for devices, although we won't be deploying to the iPad. I'm going to create this with a Git repository, and I'm just going to save this to my desktop so I can press create. And I'm going to go over to my storyboard and we're going to get started setting this up. So I'm going to just close my left panel here in order to give myself a bit of space to work with. Now, we're going to go ahead and deploy this to the iPhone 6. If you want to deploy this to a different device, feel free to do so. And in order to give ourselves enough space to work with the iPhone 6, we're going to go ahead and switch this width to be compact and our height will be regular. So we're going to choose this bottom left-hand option here. And we'll see compact width and height regular, and this will give us a good screen size to work for the iPhone 6. Now, we're going to once again use an image view as the background. So let's go ahead and select an image view. Let's just drag this in. And let's go ahead and try to update the size inspector here. We're going to set the width to be 375 and the height will be 667. And this will give us enough space in order to fully set the background for an iPhone 6. Now we also want to add a few additional UI elements. We need a toolbar at the bottom here. So let's go ahead and drag in a toolbar. And let's just add this to the bottom. And let's align this with the bottom of our image view. And let's also change the width to be 375 so it matches up with our image view. And once again, I kind of like the button on the right hand side. So we're going to go ahead and add a flexible bar button item, a flexible space bar button item to the left here. And this will move our button over to the right. And we can go ahead and change this name here to be next, the same way we did with our Lions and Tigers project. So this UI is going to be somewhat similar. We're not really focusing on setting up UI right now, just really practicing code. How do we set up a struct, and then how can we use a switch statement? So we also need a label. So let's go ahead and search for that in our object library, and let's just drag this in and we'll drop it right here. It doesn't really matter where we put it, but let's go ahead and enlarge this a bit. Give ourselves a bit more space to work with here. And we can just type in balloons in for now. And we'll display what number balloon we're on right now. Let's also just change the color, and we'll set this to be white. It'll stand out a little bit better. And if we wanted to, we could also make this bold, so we could just switch this to system bold, so it's even a little bit easier to see on our image view here. Now, the final thing we want to do is we just want to hook everything up to our view controller. So let's go ahead and open up our left-hand pane again, and hold down the Alt key and press on viewcontroller.swift. And then we can close both of our panes once more. And we're going to hook up our 3 elements into our view controller here. So the first thing we're going to hook up is going to be our label. So let's control drag to our view controller here, and we can name this balloons label. And this will be type UI label. We'll make sure this is an outlet, and the storage type will be weak. And let's also hook up our image view so we can dynamically update the image for our background here. And we'll call this background image view. And finally, let's hook up our button, and we'll make this an IB action. So we're going to make sure we have our button selected in our view controller scene here. And we'll scroll to the bottom here. And I like to hook this up from the view controller scene. That way I can be sure I'm hooking up my button. And we're going to drag in, and we'll make this an action. And we'll call this action next balloon bar button item pressed. And we'll make the type UI bar button item, and we can connect this up. So this should be the name of your IB action here. So we've now set up our UI, and in our next lecture, we'll set up a struct, or the ability to model the information that our balloon will need in order to tell us what balloon we're on, as well as what image we should be using for this balloon. So now that we have our storyboard set up, we next want to set up a struct. So let's go File, New File, and we're going to choose iOS Source, Swift File. We're going to choose Next, and we're going to call this Balloon, and we can press Create. And remember that we need our keyword for our struct here, so we're going to say struct balloon, and notice that we're using a capital B here. And then let's add some curly braces so we can actually add some properties to our balloon struct here. So the first property we need is a number. So we're going to say var number is equal to 0. And then we want a UI image property. So we're going to have to import UI kit so we get access to the UI image class. So we're going to say var image is equal to UI image, and we'll do named, and we'll just pass in an empty string for now. So this is just our struct here. We're using the struct keyword, and we're going to call our struct balloon, and it's going to have 2 properties. The first property is going to be a number, so we're going to be able to keep track of what balloon we're looking at. And it's also going to have an image, and right now we're just going to use a placeholder for our named element. So when we create our UI image, we'll be able to initialize it with just a non-existent image, but we'll make sure we update both of these properties when we actually create our balloon struct instances. And remember that we have to import UI kit so we get access to UI image. So now that we have our UI set up, we're going to go back to our viewcontroller.swift file and make some updates. And the first thing we're going to do is we're going to add a property that's going to be an array. So we'll say var balloons. And we're going to specify that this is going to hold our balloon instances. Specifically, we're going to add 99 instances to this array. And in order to do that, we're going to create a helper function. So we'll do that at the bottom here. And the real reason for this helper function is to abstract away a bunch of logic that we would normally write in viewDidLoad into its own function, so we can practice calling a function and also get used to the idea that we want to keep viewDidLoad as clean as possible. So all of this code, we're going to have to write quite a few lines of code here, would normally sit in viewDidLoad, and that would make viewDidLoad very messy. So we can just write this all in a helper function, call that helper function in viewDidLoad, and it'll just keep our code a lot cleaner. So we're going to write func create balloons, and we'll add our parentheses here. This has no parameters and does not return any values. And we'll add some curly braces. So we're going to write for var balloon count and we're going to set this equal to 0. And we'll say balloon count must be less than or equal to 99. And we'll say plus plus balloon count. And we'll add our curly braces here. And then what we're going to do here is we'll create a variable that will be an instance of our balloon. So we'll say var balloon is equal to balloon, and we'll just initialize it. So we have a balloon instance, but we haven't set up any of its properties yet. So the first thing we want to do is we want to set up the number property, and we want each balloon instance to have a different number, right? We want this to increment each time we press the button inside of our application. We want to show a different number. Well, how can we do that? Our balloon count is going to start at 0 and it's going to go all the way up to 99. So we can just say balloon dot number is going to be equal to the balloon count. And then what we can do is we can create a constant, and we'll make this a random number, and this random number will allow us to randomly pick one of the 4 balloon images we'll add to our project in just a second. So we'll say let random number equal, and we'll say int arc for random underscore uniform, and we'll do UI int 32, uint 32, excuse me, and we'll pass in 4. So we want to get 0 through 3 back because we have 4 images. So now let's add our images. So I've already saved these to the desktop. If you haven't downloaded them yet, please go ahead and do so. And I'm just going to drag this into supporting files. I'm going to make sure I have my options selected the same way. Copy items if needed, create groups, and add to targets here. And we can press finish. And then we're going to go ahead and add a switch statement. So this is a good time we can practice a switch statement. We're going to say switch random number, and we'll be able to assign a random image based upon the random number that's generated, and we'll just use our cases to determine which image should be assigned. So we'll say switch random number, and we'll add our curly braces here, and we'll add a first case. So we'll say case 1 colon, and we'll say that this is going to be balloon dot image is equal to UI image named. And where are we going to get these names from? Well, let's just open up our assets here. We see red balloon 1.jpg all the way through 4, and this top Berlin TV tower we'll just use as our background. So we're going to say named red balloon 1.jpg, and then we'll add a second case. We'll say case 2, and oh, this needs to be inside of our curly braces, so let's just add a couple of returns here. We'll say case 2 balloon dot image is equal to UI image named red balloon 2.jpg, and then we'll do case 3 balloon dot image is equal to UI image named, and we'll do red balloon 3.jpg. And finally, we can have a default case. So we'll say default balloon dot image is equal to UI image named, and we'll do red balloon 4.jpg. And that finishes our switch statement. Finally, we want to add our balloon instance to our balloons array that we set up earlier here. So we're going to say self.balloons.append, and we'll pass in our balloon instance. Now let's go ahead and go over this code. I'm just going to quickly remove these spaces to clean up this code a little bit. Right now, we're not setting up the array because we're actually not calling this function in ViewDidLoad yet. We'll do that in our next video. But we did set up a function, and when we call this function create balloons, we're going to generate a for loop here. And this for loop is going to run from 0 to 99 by incrementing the variable named balloon count. So we're going to set its initial value to 0. We're going to specify that it must be less than or equal to 99, and each time we run through the for loop, we'll add 1 to the balloon count. Then we create a variable, and this is just a default instance of our balloon. So each time we run through this for loop, we'll generate a new instance of our balloon. And then we set the number of our balloon equal to the balloon count. So each time we run through the for loop, we'll have a different balloon count number here. So all of our balloon instances will have a different number. And then we want to figure out how to randomly assign an image. So we create a random number and we specify that we want 4 possible numbers, 0 through 3. And then we use a switch statement on our random number. And depending on what random number we pass in, we'll either have case 1 where the number is 1 and we'll have red balloon 1.jpg. If the case is 3, our random number was 3, and we'll use red balloon 3.jpg. And if the random number is 0, our default case will evaluate and we'll get red balloon 4.jpg. The final step we do inside of this function is we actually add our balloon instance to the balloons array, and we'll be able to use our balloons array to update the UI in our next lecture. So we want to finish up solving this challenge in this lecture. And the first thing we need to do is create another property. And we're going to say var current index is equal to 0. And we're going to use this property instead of storing items like we did with our balloons property. We're going to use this index to track what index we're currently displaying on the screen, so we can increment our balloon that we're showing on the screen each time we press the button, so we're not showing the same balloon over and over again. So by setting its initial value to 0, we're saying, okay, we're going to start with the first instance on the screen. And let's go ahead and update the function named next balloon bar button item pressed. And we can first grab an instance of our balloon. So we're going to say let balloon equal balloons, and we'll index into this using current index. So each time we press the next button, we're going to grab the next balloon, and this number will increase. So it'll go 0, 1, 2, 3, 4, 5, so on and so forth. And we'll be able to grab a different instance of our balloon from our balloons array. And we're going to set that equal to the constant name balloon. Now we can say balloons label dot text, and we're going to set this equal to our balloon number. Now in order to do that, we're going to have to do a little string interpolation here. So we'll say balloon dot number, and then we'll say balloon. So we'll have a number, and then it'll say like 1 balloon, 2 balloons, so on and so forth. And then we can add a background image for our balloon here. So we're going to say background image view dot image is going to be equal to our balloon image. And finally, we're going to update our current index. So we'll say current index plus equals 1. We'll use our shorthand here. So each time we press this button, we're going to add 1 to the current index. So we're using our balloons instance that we're going to get back from our balloons array to update both the balloons labels text property as well as the image for our background image view. Now the final thing we want to do here is we want to actually call the function create balloons inside of viewDidLoad. So we're going to put create balloons, and we'll make sure we put our parentheses here so we know we're calling it. And once again, we could use that self keyword to actually call this function, right? So we can say self.createBalloons, and this will actually call this function. We want to make one final change before we run our project, and that's in the main storyboard. Let's select our image view, and let's update the image to the Berlin TV tower. So we'll have a default image that we can show off to our users before we start, scrolling through all of the balloons. Now let's go ahead and run our application. And we can check if this thing works. So we see balloons populates here, and we press next, and we see 0 balloon. This doesn't show up too well, but that's our second balloon, and so on and so forth. So we can see all these balloons showing up here. Now we could, make this black or a different color if you really wanted this to show up. But the real point of this challenge is, did you understand how to make a struct, how to encapsulate some information, and then we also learned a little bit about functions. Specifically, we practiced using the self keyword and creating a helper function and then calling that in the view controller to try to keep our viewDidLoad function a bit cleaner. It's time to start learning about classes. Now, classes are very similar to structs, and I've actually gone ahead and copied a little bit of the Apple documentation here so you can see all the similarities between classes and structs. Now, let's just take a look at the first two here. We're able to define properties and structs, which we saw, and we're also able to define properties and classes. So this is going to be very familiar. We're also able to define methods, or as we've been calling them, functions, to provide functionality in both a struct and a class. So this is very similar. We have some additional similarities here, but we're going to get to these at a later state in our course. But things like being able to conform to protocols, being able to use initializers, we'll definitely be covering these in the course. So you can expect these later. Now, there are differences between classes and structs, and we're going to be focused on the first item here, which says inheritance enables one class to inherit the characteristics of another. This is not possible with structs. So what does this mean? Well, let's go to another Keynote slide here. And this might look similar to the Keynote slide we had for our structs, right? And basically for our struct, we had a single blueprint and we were able to create many different instances of a car from that. Well, for classes, we have what's called inheritance. So at our top level here, we have what's called a car class, and our car class could define something like the number of wheels, right? All cars should have 4 wheels. The number of doors, or the fact that it should have a windshield. Now, what we can do is we can define all of these things, but then we can create what's called a subclass of our car class, and that would be our basic car class or a sports car class. And each subclass can create instances of either basic car class or sports car class. But both of these subclasses share certain properties or functionality, the ability to drive from point A to point B, that's created in this car class. So what this allows us to do is it allows us to write a little bit less code, because we're able to say, okay, what items do these two classes share? And let's just put that in our car class. We only have to write that once, and then we'll just inherit from that car class, and we'll be able to set up 2 separate but very distinct classes which can both create instances. Now, if that's not 100% clear, we're going to create a subclass and be able to see what the difference between a subclass and what we call is its superclass, right? The superclass of our basic car class would be our car class, and figure out kind of how that really differs from structs, which can't create a subclass of itself in order to pass functionality onto another class. So it's now time to create a lion class instead of a tiger struct. The first thing we're going to do is we're going to go to our models group here, and we're going to go to File, New File, and we're going to choose iOS source Swift file. We can choose Next, and let's call this lion. So we can go ahead and create this, and instead of writing struct lion, we're going to write class lion. And this is going to be the basic way in which we're going to create a class here. Now, one of the things we're going to need to do is we're going to need to import UIKit, because we're going to need to add a UI image later. So let's just go ahead to the top and do that right away. And our line is going to have some properties. So we're going to say var age is equal to 0. Our line is also going to have an age, and just like our tiger. But we're going to add a different property here. We're going to say var is alpha male, and we're going to set its initial state to be false. So this is a bool. Our line is also going to have an image, and we're going to say UI image named, and we're going to do double quotes here. And our line is also going to have a name. So we're going to say var name is equal to, and we'll just do double quotes. Instead of doing breed, we're going to do subspecies. So we're going to say var subspecies is equal to double quotes. So this is also going to be a string. So how do we create an instance of our lion? Well, we can go back to our view controller, .swift file, and let's find the viewDidLoad method. And we're going to scroll to the bottom here under our self.tigers, and we can create our first lion instance. So the first thing we're going to do is we're going to say var lion is equal to lion, And we're going to do our parentheses here, which is the way we can initialize our lion instance, just the way we did with the struct. And we can also set up properties the same way we did with our struct. So as we saw in the keynote slides, right, the similarities between a class and struct, we could set properties and create properties for both classes and structs, and we could also create and call functions for both structs and classes. So this was the overlap. So let's see how this works. We're just going to set the age equal to 4. We're going to be able to say lion.isAlphaMale is equal to false. Lion.image is equal to UIImage named, and let's do lion.jpg. And we're also going to give the line a name, so we can say the lion.name is equal to Mufasa. And the lion subspecies will be West African. So as you can see, we're able to create an instance of our lion the same way we were able to do with our tiger. If you're interested, you could print out the information for our lion. So let's just try doing that real quick. We're going to do print line. And we're going to say the lion's age is, and we can do lion.age. And we can also print out the name for our lines. We can do, and let's do this in the quotes. And the lion's name is, and we'll put in lion.name. And let's also print out the subspecies. And the lion's subspecies is, and we'll put in lion.subspecies. And let's go ahead and run our application. Let's take a look at what everything looks like when we do run it, and let's take a look at what our console prints out for us in terms of the attributes we've set up for our lion here. So let's take a look at what printed out in our console. And we're going to be able to see that the lion's age is 4, and the lion's name is Mufasa, and the lion's subspecies is West African. So we were able to set the properties of our lion instance the same way we were able to do with our instance of our struct. The class is working the same way when it comes to properties. So with that working properly, let's go ahead and just create another lion instance while we're here. We're going to be able to say var lioness, make a female lion this time, and we'll say lion, and we'll initialize it. We're going to say lioness dot age is equal to 3, and lioness dot is alpha male is equal to false, and we're going to say lioness dot image is equal to UI image named, and we're going to do lionS.jpeg, and let's do lioness.name is equal to Sarabi, and we'll say lioness.subspecies is equal to Barbary. Now, one thing to notice here is that we're going to do lioness.jpeg instead of .jpg, and that's because the lioness, if we take a look here in our assets, is a JPEG file. So it's important to use the right file extension. If you don't, iOS won't be able to find the correct image, and your computer program won't display the image, and it'll look funny. So it's important that you get the right extension here. So now we've been able to create a second lion instance, and if you wanted to, you could print out all the information again. We're not going to do that because that feels a little bit redundant. But we now have 2 instances we're going to be able to use to display in our application. Now, in this video, we're going to figure out how to create another array in which we can add all of our lions, because we're not able to add our lions to our tigers array. Remember that we're only able to add one type. Specifically, in this case, we're only able to add one class type into a particular array, and tigers already has the tiger struct in there, so we can't add our lions into the tiger struct. So how are we going to do this? Well, let's go to the top here and let's create another array. We can say that this is going to be var lions. And we're going to go ahead and say that, yep, there are in fact going to be lines in there, and we're going to initialize our array. Now, notice that I didn't say like my lions. I actually don't love saying my tigers. I'm really doing this to show the difference between the two variable names, and again, that, you know, we don't always have to just pluralize whatever the type we're going to be putting in there. Or what if we had two lions arrays, right? Would you say like lions array 1, lions array 2? There's a lot of different ways you can kind of create your variable names here. So I'm just calling this var lions. You could call this var my lions. It's kind of up to you. So let's go back down here and let's go ahead and add both of my lions. And I can do this in a single line of code. We can just say self.lions plus equals, and let's do our bracket notation. So we're going to say lion, comma, lioness. And this is going to go ahead and add both of my lion objects or instances into my lions array. And notice that I'm using the self keyword here. This is, again, is not strictly required. And you're going to see quite a bit of code written without the self keyword. So it's interesting to see it written both ways. But again, I'm just really trying to point out wherever we can this use of the self keyword. Lions is a property inside of this view controller class, and we're going to be able to access that using the self keyword with the dot notation, so self.lions. We could also have appended each one of these lines individually, but I think it's cool to just do them all in one line like we did here with our notation plus equals, and then we added both our lion and our lioness into our array. In this video, we're going to be learning about a really cool new type introduced in Swift called tuple. And tuples basically allow us to package multiple bits of information, or multiple variables or constants, inside a single variable or constant. So let's see how this works. We're going to go ahead and create a new playground. We're going to call this tuple. And we can go ahead and enlarge this here, remove this default string that they give us. And the way in which we create a tuple is we're just going to say var my tuple is equal to, and sticking with the theme of tigers, let's package the information for Tigger. So we're going to say Tigger, it's going to be the name, and it needs to be in quotes, Tigger. And we're also going to say that the breed is Bengal, and the age will be 3. And we're not going to bother to do an image. So we're able to package 3 bits of information here. And if we wanted to get this information out, we could do a print statement, and we could do our variable here. We need the quotes. And we could say my tuple dot 0, and this will give us the first element in our tuple. So kind of similar to an array. Let's go ahead and go to our assistant editor here and take a look at what print statement. So it shows Tigger. If we indexed into the third element in our tuple, we would see that we get the number 3 back. So it's kind of similar to an array. It's a great way we can package information. This is going to be really useful later on when we want to return multiple items from a function. We can actually return a tuple, which is really powerful. And what we're going to be using our tuple for is going to be a property, and we're going to be able to store multiple bits of information together as well. So this is super handy. One of the other things we can do with a tuple is we're going to be able to actually give our values here some sort of key. And this is a little bit similar to dictionaries, if you've seen dictionaries in other programming languages. But let's go ahead and create another tuple. So we'll say var, second tiger tuple, and we'll set this equal to the first. We'll say name colon, and we'll say tigress, and comma, and we need a breed. So we're going to do breed colon, and we'll do Indo-Chinese tiger. And finally, we need an age. So do age colon, and we'll set its value equal to 2. So now, instead of having to use or figure out at what spot in the tuple the information I need, we can just use these these names. So we can say print line, and we're going to be able to say quote quote, and we'll say second tiger tuple dot name, and we'll see tigress comes out. We could switch this to breed, and we'd also be able to see the breed of the tuple that I created here. So there's one really cool thing I want to show you that we can do with tuples, besides storing multiple bits of information together, and that's we can combine a tuple with a switch statement. And let's just jump right into it and see how it's done. So we're going to go ahead and say switch, and we can just use our second tiger tuple here. All right, we already have that created, so why not use it? We're going to go ahead and add our curly braces here. And what we're going to do here is we're going to first do case, and instead of just doing like case 1, case 2, we can actually do case with a specific tuple here. So the first thing we're going to want to do is we're going to want to compare the first item in our tuple. So let's make this tigress. So this one will actually evaluate to true, and we'll do comma, and we'll actually make the breed match as well. Indo-Chinese tiger. And actually I see an error here. This was okay to make this a string, but actually let's go ahead and just make that a number. We're going to actually insert the wrong number here. So the first case here won't evaluate to true. All right, but we could add some bit of code here. Actually, we need the colon. And we're going to just say print line, and we'll say, first case is true as a good way to do this. Now, to prevent these annoying errors, we're just going to create our default case next, and we can simply write a print line statement here, and we'll say default is occurring. And right now we could see if we went to our system editor here that the default is occurring. But if we switched our first case here to 2, which would match our second tiger tuple here, we'll see that first case is true. So if all of the elements match our tuple, we see that the case evaluates to true. If not, then our default is going to occur. So let's add another case, and we're going to say case spar, and we'll make this Indo-Chinese as well, and we'll set the age equal to 3, and we'll add our colon here. And for this, all we'll do is we'll say quote quote second case is true. And of course we could be doing different bits of code in here. We're just doing print lines just so we can see which one is evaluating to true. Now, one of the cool things about using switch statements with a tuple is that we can ignore bits of information. If, for example, we only cared about matching the breed, we could add an underscore for the name and the age. And let's go ahead and let's change this Indo-Chinese tiger, and we can actually set this to be Malayan instead. So we actually now see that the second case is evaluating to true, even though only Indo-Chinese tiger matches, because we changed the breed of our first case here that no longer evaluates to true. And what we're doing here in our second case is we're saying ignore the name, check to see if the breed is the correct breed, and then ignore the age. So using this underscore is a really powerful way that we can ignore bits from our tuple. So with tuples under our belt, we can go back into the Lions and Tigers project, and we can figure out why we had to take this quick aside in order to learn about tuples. Well, we have a problem right now, and that's right now we're updating our view based on a current index, and that's how we're figuring out which element in our array, or specifically our Tigers array, we should index into. Well, this isn't going to work now that we've added a Lions array. because we want to figure out how to index into both the lions and tigers array. And right now the requirement is going to be, if I'm showing a lion, I want to show a tiger instead. And if I'm showing a tiger, I'd like to show a lion instead. Well, how can we make this happen? We need to figure out and store as a property both the current animal that we're showing as well as the current index of that animal, right? We don't want to keep showing the same index over and over again. So let's scroll to the top here, and we're going to create a property that's a tuple. So we're going to say var current animal is equal to, and we'll say species, and we'll set its initial value to tiger, and we'll say index, and we'll set its initial value to 0. Now, why does this work? Well, we know that we're initially going to update our view with a tiger, and that tiger is going to be added to at index 0 to the my tigers array. So this is accurate. This is a really great way to start off our current animal. So what is the next thing we need to do? Well, we're going to create an additional function rather than kind of overriding all of the code inside of the next bar button item. We're going to create a helper function, and inside this helper function we're going to figure out how we can update our current animal based on what the current tuple, or based on what the information in the tuple property is. So let's go and create a function, and we can call this update animal. And this function isn't going to return anything. It's not going to take any parameters, so that's fine. We can get all the information we need from the property. So we're going to run a switch statement on our current animal. And let's add our curly braces here. And the first case is going to be for tiger. And we're not going to care about what the index is. So let's put a colon after this. And we're also going to define what the default case should be. So we could say default colon. So what we're going to do here, if it's currently a tiger, we want to switch the current case into a lion. So let's say current animal is equal to lion. But we don't have an index yet. So we're going to want to generate a random number for this index. So we know how to do that. We're going to say let random index equals arc for random uniform, and we're going to do UI int 32, and we're going to do lions dot count. And this will give us back a random index, and then we can insert the random index into our tuple here to update our property. Now we're going to want to do the same thing. I got a typo up here. UI int. We're going to want to do the same thing with our default here. So if it's a default, we know it's going to be a lion, so we want to switch this over to a tiger. And again, we're going to want to generate a random index and store that in our tuple. So let's go ahead and generate another random index here. We can say let random index equals arc for rand uniform, and we're going to say UI int, u int unsigned int 32, and let's do my tigers dot count, and then let's update our current animal. So we'll say current animal is equal to tiger, comma, and then let's pass in our random index. Now we have one little error here. I hope you caught it. Maybe you did, maybe you didn't. And that's right now we're not converting our number that we get back into an integer. So let's go ahead and convert these so that we're able to properly update these things. That's one too many. And we can also convert the second one here. And now we're using the proper type, and this can happen, as you're coding, you forget to, do the int here, and just go back and, you're able to now add integers into this tuple because we've initially said that we want only integers in here, right? So the index is 0. So we don't want an unsigned integer. We want just a regular integer, and this is the way we can create a regular integer using this int function, and we pass in the parameter of our unsigned integer. So with this update animal function, we're going to be able to call this in our next bar button item pressed, and with this we're going to be able to update and save what the current animal is. So this is the first step in order to update our view with both lions and tigers. So we're going to figure out in our next video how we can actually implement this and make our view update. So let's go ahead and first do a little bit of refactoring here. We're going to move the code out of our next bar button item pressed function into a helper function so we can save this, but what we're really going to be doing is we're going to be using the update animal and an additional function we're going to write shortly. And this will allow us to just swap the two bits of function in and out really quickly. So let's quickly create this helper function. We're going to say update tiger, and we're going to add a pair of parentheses here. We don't need to put anything in them, and we're going to add our curly braces. And all we're going to have to do is we're just going to cut all of this code except for this print line statement, excuse me, and we're going to just drop that right into update tiger. Now what I've done here, actually let's go ahead and just adjust this curly brace so it lines up nicely. So what I've done here is I've just basically moved all this code into the update tiger function, and what I could do is I could call update tiger, and this would run exactly the same. But what I'm going to do is I'm actually going to comment it out because we're not going to be using that for now. We're actually going to be using the update animal, so I'm going to call that when I press the next bar button item pressed button, and I'm going to first update the animal, and then I'm next going to create another helper function, and in this function I'm actually going to go ahead and do the UI update for either the tiger or the lion. So we're going to say func update view, and we're going to go ahead and add our parentheses and our curly braces here. And let's go ahead and just copy this crazy code here. We don't have to type this all out again. When possible, it's always nice to copy and paste code that works. So let's go ahead and just delete these previous bits of code inside, but we know we're going to be able to do our nice transition again. I really like the view transition here. And we're first going to have to do a little bit of if logic here. So we want to determine if the species is a tiger or if it's a lion. So let's say if self.currentAnimal.species, remember we were able to access a specific value from our tuple using its name, so we're going to use species here, is equal to, and we're going to say tiger. Let's add some curly braces. Well, in this case we're going to want to go ahead and index into our tigers array, so we can say let tiger equals self.mytigers, and let's index into the mytigers array. So we're going to say self.currentAnimal.index. That's some pretty crazy code there. Let's talk about what's going on. We're first checking using the dot notation our tuple, which is our current animal. We're basically saying, is this a tiger? And once we're sure that we have a tiger, right, that this should be the current animal in that we want to be accessing, we're going to go into our tigers array. So we're going to say self.mytigers. We're able to use the self keyword here. And maybe you remember that because we're in a closure here, we actually have to use the self keyword. So this is actually required here. So we're going to say self.mytigers, and then what we're going to do is we want to get a specific tiger out of the mytigers array. Well, what index should we use? Let's use the index we saved in the update animal function. So we're now able to say self.currentAnimal.index, and we set that index in the update animal function. We're going to call that update animal function in the next bar button item pressed. So when we press a button, we're going to update that index, and we're going to be able to index into this array. And notice that we use the count of both of our arrays here, so we're sure that this index is valid. So next what we want to do is we want to update each of the elements on our view. So we can say self.myImageView.image is equal to tiger.image. And we can say self.breedLabel.text is equal to tiger.breed. And we're going to be able to say self.ageLabel.text is equal to quote quote, and we can do tiger.age. And finally, we want to update our name label, so we're going to say self.nameLabel.text is equal to tiger.name. Now let's also do an else statement here. And you know what? Let's actually be explicit. Let's be sure that this is in fact a lion, just in case we add additional animals down the line, which we will do. So we're going to say self.currentAnimal.species equals lion. And if it's in fact a lion, we need quotes here because we're going to check to make sure it's in fact a string. We're going to say let lion is equal to self.lions. And the same way we did with the tiger, we're going to say self.currentAnimal.index. And then we're just going to update our UI. So we can do self.myImageView.image is equal to lion.image. And the breed label, so we're going to say self.breedLabel.text is equal to lion.subspecies. So this is a little bit different. We have a different property name for our lion. And let's also update the age. So we're going to say self.ageLabel.text is equal to lion.age. Actually, we want to put this in a string. We're going to do some string interpolation here. So let's say lion.age. And finally, let's update the name label. So we're going to say self.nameLabel.text is equal to lion.name. Now, one item we're missing here is the random fact. So tigers have random facts and lions don't. So what we could do here for the time being is write self.randomFactLabel.text is equal to tiger.randomFact. And when we have our lion, let's just go ahead and hide this thing. So we can say self.randomFactLabel.hidden is equal to true. And we can do a little bit of refactoring later. We'll add a function to give us a random label so we can have random facts about both lions and tigers. But for now, we're just going to hide it. So let's call this function when we press the next bar button item. Now, order is really important here. If we try to put the order or call the function updateView before we update the animal, this computer program won't work the way we had hoped it would. We're not going to be updating the current animal and then figuring out what the view should look like. We're going to update the view and then update the current animal, and that doesn't make any sense. So make sure that you put update view after you update the animal. And notice that these are just helper methods. We're just kind of putting bits of functionality that we feel go together. You know, this is just responsible for updating the view. This is only responsible for updating the animal. And notice how clean our next bar button item pressed is now that we've done this. Even with update tiger, right, we were able to refactor all of this code into its own function. And even though we're not using it, it's really easy to swap between these two different functionalities if we wanted to. So let's go ahead and run our computer program here. And let's check to make sure our computer application is working properly. So we can press next, and we see our line is coming up now. We were able to hide the random facts. We don't have one yet. And we now see our tiger. We have one little bug here. It's not unhiding our random fact label, so we could easily fix that. But we're now able to transition between the tigers and the lions, and we see that we are in fact getting random tigers back here. We haven't gotten that. There we go. We got our Mufasa. Now, if we wanted to unhide our label, our random fact label, we would just unhide this every time we have the tiger, and we could always just set this equal to false. So feel free to rerun it if you want to see the label being unhidden. Now we're actually going to be doing a little bit of refactoring in the future in order to give our lion a random fact. So this will kind of be moot because we'll be removing this line of code anyway. So we're now going to add a function to our lion class. And the reason we're going to add a function to our lion class is that we can understand that classes can have functions the same way structs can. So we were able to add a few different functions to our tiger.swift file. And now we're going to see that we can also add functions to the lion.swift file. So make sure you have the lion.swift file selected in the Lions and Tigers project. And we're going to go ahead and declare a function. Now this function is going to be fairly straightforward. We're going to just say that it's going to be called roar. And it's not going to have any parameters, so we don't need to add anything inside of our parentheses here. And it's not going to have any return values. It's going to be just a print line statement. And we're just going to add quotes, and we can say lion, roar, roar. And remember that the reason I do line : is just as an identifier. When we're seeing all of these print statements come out to our console, we want it to be really obvious to us where roar, roar is coming from. And by adding line, it's pretty obvious that it's coming from our lion class here. So hopefully you know that in order to call this function, we need to call this on an instance of our lion. Well, where are the instances of our lion? They're located in our viewcontroller.swift file. So all we got to do is click over here and locate our two lion instances. So we have one lion here, another lion here. This is a variable named lioness. So we can say lion.roar, and this should print out roar, roar to our console. And if we say lioness.roar, we should see it print out twice to our console. So let's go ahead and run our computer program here so we can confirm that functions work the same way for both structs and classes. So we see roar, roar prints out twice. In this video, we're going to be creating another function that's going to update one of our properties. Now, I'll admit that this is a little bit contrived because we could just change the property in our view controller by just setting it with the dot notation. But it's really going to point out a difference between a class and a struct. So let's get right down to it. We're going to jump right in here. We're going to go into our lion.swift file. And we're going to say func change to alpha male. And this is not going to return anything, so we don't need to add anything inside of our parentheses here. And all we're going to do is we're going to write self.isAlphaMale is equal to true. Now, the difference between a class and a struct, or one of the differences here, is that in a class we can access our properties, whereas in our tiger struct we were not able to access age, name, breed, or image inside of our functions here. So if we tried to go into random fact and we wanted to access breed and set this to a new value, we'd get an error here, right? Cannot assign to breed and self. And even if we try to use the self keyword here, you might say, okay, maybe that'll fix my problems. We see that again, this is not going to work. However, in our class, we are able to access our properties, and we don't even need to use the self keyword. This isn't required. But we can use the self keyword because this is a property, And again, we're just going to try to really get comfortable with the self keyword. I'm going to keep inserting this through all of our videos. So hopefully, as you get far along the course, self will just start making sense, when to use it, when not to use it. So in this function, all we're doing is we're saying, okay, the initial state of is alpha male, right? And by state, I mean the bool value here is set to false. And all we're going to do is we're going to set it equal to true. So how can we do that? Well, let's go into our view controller here and let's find our lion. So it doesn't really make sense to make our lioness the alpha male, but we can change the lion here. And this bit of code here is a little bit redundant because the initial state is set to false. We don't actually have to explicitly say that, but that's fine. We can leave this bit of code. Let's go down here. We're going to say lion, and we can do change to alpha male. Now, to confirm that this is, being set properly, we could write some sort of if statement after this, and we could write if lion dot is alpha male is equal to true, and we could just write a print statement here. So we could just write the lion is now an alpha, and we could just go ahead and run our computer program here. And we should see the line is now alpha print out to our console here. So the real idea here is, again, to practice making a function. But what we're really learning in this lesson is that in a class, we have the ability to access our properties inside of our functions, whereas in structs, we do not. So that's just something to keep in mind as we're learning more about properties and functions and the difference between classes and structs. So in this video, we want to set up a function that's going to return a random fact for our lion. But we're going to do this a little bit different than our tiger, where we just kind of created a random number. We're going to use the property isAlphaMale to determine, which kind of random fact we should display on the screen. So let's go ahead and let's create our function here. We're going to call this random fact. And let's go ahead and say that this is going to return a string here. And we're going to say var random fact. And this is going to be a string. We don't know, what its value is yet, but we're going to decide what its value is going to be based on an if statement. And we can write if isAlphaMale equals true, random fact is equal to male lions are easy to recognize thanks to their distinctive means. And let's add just another sentence here. Males with darker means are more likely to attract females. And hopefully that seems pretty relevant. We are talking about an alpha male here. We also need an else statement, and this else statement is going to be for our lioness here. So we're going to say random fact is equal to female lionesses form the stable social unit and do not tolerate outside females. So the final thing we need to do for this function is we need to return our random fact. And we see that it keeps autofilling my function. It's because I name my variable and my function the same thing. If you want to change these, it's fine. But it's kind of nice here to figure out, okay, well, when I have the parentheses, I'm referring to the function. But when I use random fact, I'm referring to the variable that's a string. So let's just go over this code one more time. The first thing we're doing is we're creating a function, and its name is random fact. It has no parameters, so we're leaving our parentheses blank or empty, and it is returning a string. So what we first do is we create a variable named random fact, and we're specifying that it's going to be a string. But we don't give it a value yet. We're going to give it a value based on our if or else statement. Then what we're saying is if isAlphaMale is equal to true, if my property is true, and again, I'm accessing my property inside of a function. I can only do this in classes. I can't do this inside of a struct. I'm going to assign the random fact for my male. And if it's not an alpha male, we'll just say that, okay, let's use the female bit of text here. And then we're going to return our random fact. Now, you might be saying, well, this is a great use case for using self, right? So we could say self is alpha male. And we see that both ways are valid. And also you could refactor this. You don't need to do the comparison equals true, because simply saying if self is alpha male is the same thing as saying if self is equal male equals true, right? We're saying, is this statement true? Is this bool true? So let's go ahead and update our viewController.swift file. And if you remember, we had just hidden our random fact label for our line because we didn't have a random fact yet. But what we can do right now is we can delete both of this random fact hidden adjustments, and let's just update our random fact label for our line now with this function we've just created. So we can say self random fact label dot text is equal to lion, and we're going to say random fact. And let's go ahead and run our application here and see if this is going to work for my alpha male or not, right? So let's go here, move our simulator up a little bit, and it should show lion. Okay, cool. It's showing my male lion text here, so that's great. And hopefully we'll get a lioness next. Oh, perfect. And we now see that it's properly figuring out that my female is not the alpha male, and it's displaying the text for my lioness. In this video, we're going to learn how we can subclass an existing class and what that means in terms of inheritance, or in terms of getting access to functionality defined in what's called our superclass. Let's see how this works. We're going to go into Xcode and we're going to just create a new file here. And we're going to choose iOS source and we're going to choose Swift file. We can select next. And we're going to call this lion cub. Now let's create this file. And this is also going to be a class, so we can use our class keyword here. And we're going to say lion cub. Now, in the past, we would just added curly braces here, like we did with our lion here. We have a class, but we want to say that our lion cub inherits everything from the lion. Now, unlike when humans have inheritance, right? We get two different gene pools. Inheritance in code is a one-to-one relationship, right? So the class inherits from one class and it gets access to all of the information from that class. Specifically, it gets access to all of the properties and functions, and it automatically knows how to do all of those things. So what does that mean? Well, let's say that this is going to be a subclass of lion, and we can say that lion is the superclass of lion cub, and lion cub is the subclass of lion. Right? Super and sub. So we now have a lion class, a lion cub class, and we can create lion cub instances now. So let's go to our view controller file here. Let's go to view to load, and we'll do this after our lion logic, right? I'm trying to keep my tiger logic at the top here, my lion logic below it, and then we're going to do our lion cub logic below that. So we're going to say lion cub is equal to lion cub, and we now have an instance of lion cub. Well, oh, sorry, I forgot the var keyword here, var lion cub. So what does it mean that we get access to all of the properties and functions of lion? Well, the lion cub now knows how to set its age, a name, an image, and a subspecies. So let's go ahead and set those. We can say lion cub dot age is equal to 1. Right? It's a cub, so we'll make it young. And we'll say lion cub dot name is equal to Simba. And lion cub dot image is equal to UI image named. And we'll say lion cub 1 dot JPG. And we also want to set the subspecies. We'll say lion cub dot subspecies is equal to Maasai. Hope I didn't mispronounce that. We also get access to all of the functions we defined inside of the lion class. So let's just pick a function. We can take a look here. We have roar, change to alpha male, and random fact. Let's just use roar right now so we can just see a print statement. So let's go down here and we can type in lion cub dot roar. And to make this really obvious that this is the proper roar, let's just add a print line statement above this. And we're going to say lion cub should roar after this statement. All right. And let's go ahead and just run our application here. And then we'll talk about what's going on here. So we see lion cub should roar after this statement, and then we see roar roar. So what's happening here? Well, the lion cub, even though we didn't add anything to this file other than setting it up and saying that it's a subclass of lion, automatically got access to all of the properties and all of the functions that we defined in our lion class. So it got access to be able to set its age, is alpha male, name, subspecies, and it got access to all of the functions. We were just able to call the function roar on our lion cub. So that's pretty cool. Now, one of the things we're going to be doing in our next video is we're going to be adding functionality onto our lion cub subclass. And this basically means that we can add additional functionality to the lion cub, but our lion superclass won't know anything about that. But if we make changes to our lion class, the lion cub class will automatically be able to get access to all of those changes as well. So let's get started building out our lion cub subclass. Well, the first thing we're going to do is let's just make a very basic function to once again prove that this is another class and we can create functions that are distinct only to the lion cub class. So we're going to say func, and we're going to say rub lion cub's belly. I think that they like that. We're going to add 2 parentheses and a set of curly braces here. And basically, we're not going to return any values, no parameters, really straightforward function. We're going to print a line here. And again, let's add an identifier. And we're going to put in here that the lion cub is going to snuggle and be happy. So we now have this function. We know that we need to call this on an instance of the lion cub. And hopefully you can guess that this is located in our viewcontroller.swift file. So we can say lion cub dot rub lion cub's belly, and let's go ahead and run this. So we should be able to see, that it's going to snuggle and be happy. Print out to our console here, and that's exactly what we see. So this function works properly. Now, I just want to point out that adding a function to our lion cub class does not mean that lion will know about it. So if we try to go up here and we try to say lion dot rub lion cub's belly, and we see that we don't even get an autocomplete, which should be a big red flag that we're doing something wrong here. We're going to get an error here, and it's basically going to say lion does not have a member named rub lion cub's belly. And basically, we didn't define this function in the lion class. So just remember that with superclasses, right, they don't know what's going on in the subclass, but our subclass gets everything from our superclass. Well, that's not really enough, right? We need to do a bit more here. And the next thing we're going to learn about is that override keyword we saw in our view controller. So actually, let's just run back over here real quick. And we see override func view did load, and we see override func did receive memory warning. Well, what does this override mean? Well, if there is a function in our lion superclass, so we're going to grab roar, and we want to add some additional functionality, or we just want to override it completely, we can use the override keyword. So let's say override func roar, and let's add our curly braces here. We're going to say print line, and let's say lion cub. And I think lion cubs growl. They don't quite know how to roar yet. It takes a little bit of time for them to get old enough to learn how to roar. So let's go ahead and rerun our application. Notice that we're calling the lion cub roar here. And let's see what happens here. So we see that lion cub should roar after this statement, and then we see growl growl. So what's happened here? Well, instead of roaring like we were before, by using the override keyword, we're actually completely overriding what should happen inside of this function, right? So we're not forced to stick to the functionality inside of our lion class. We can actually change it and make it our own based on our subclass here, or in our subclass here. So there's another cool keyword we can use when we're talking about inheritance, and that's the super keyword. Well, we've actually seen that before. If we go to our viewcontroller.swift file and we look at our viewDidLoad function, we see super.viewDidLoad. Well, let's figure out what this means. Let's go into our lion cub Swift file. And right now we're overriding the function roar. And what this is doing is it's completely overriding the functionality of roar. However, what if we wanted to include the functionality from our lion's roar? So we'll have lion roar roar. And then we wanted to have our lion cub growl growl. Well, we could easily do this by saying super roar. And what this is going to do is it's going to basically say, okay, when we call the function roar on an instance of the lion cub, go ahead and evaluate all the code inside of the implementation for our lion function for roar. So we're going to just run this one line of code here. And then go ahead and add any additional functionality, which would be just printing out lion cub growl growl. Let's see if this works. Let's go ahead and run our project here. and we're going to see growl, growl. But before that, we see roar, roar. So the super keyword allows us to use functionality from our superclass's function, and then we can extend that or add our own additional functionality on top. Now, why do we see this in viewDidLoad? Well, we want to add our own additional functionality into viewDidLoad, but viewDidLoad itself has, some setup stuff that goes on here. We can actually hold down the command key and press on viewDidLoad, and this will actually take us to where this is defined in the Apple UI View Controller class here. And it tells us a little bit about this. Now, unfortunately, we can't see the implementation of viewDidLoad. Apple keeps this private, but this is a really handy trick if you want to figure out, kind of what's going on here, what kind of comments is Apple putting here. And Apple actually tells us that viewDidLoad is called after the view has been loaded. For view controllers created in code, this is after load view. All right, so we'll talk more about the view lifecycle in a later video. But for now, it's pretty cool that we're able to use the super keyword in order to gain access to functionality. And I just showed you that if we hold down the command key, we can press on these Apple-defined keywords here, and we're able to figure out more about this function. Or we could even do this for these classes like UI label. We could hold down the command key and press on UI label and figure out more about what kind of properties are available inside of the UI label class.